Hey everyone, and welcome to the course. My name is Daniel Buckley, and I'll be your instructor. In this course, we are going to be learning the Godot game engine. Okay, Godot is a game engine that is rising rapidly in popularity as it is a very versatile platform in order to build 2D, 3D games. Pretty much whatever sort of game you want to create, you can do that with Godot. And throughout this course, we are going to be learning from the ground up how to go from having no knowledge whatsoever to creating your first ever game. Now, Godot is a free to use and open source engine which has been around for quite a while now. And as the years go on, they are adding ever more features. So this engine is consistently getting upgraded and worked upon, which is very exciting, as if you are someone that is looking to get into game development, then Godot is a very highly recommended engine to begin with, as it is quite user-friendly, it is very lightweight, and it also has its own included code editor, so you don't have to download any other external programs. Everything's self-contained in the engine, so you can get started right away. Now, in this course, we are going to cover a wide range of different topics. First of all, learning the Godot editor. Okay, we're going to install Godot, and then we are going to have a look at the editor itself. This is the piece of software that we are going to be spending all of our time in, creating our game, writing our code, dragging around our nodes and scenes, modifying all of those. So we're going to get an understanding of how each of these different windows work and how they are used in order to create a game. Then we are going to learn the fundamentals as well as 2D. So we're going to be learning about nodes, scenes, tools, the idea of parenting, and how to use cameras. Then, once we understand the fundamentals and we know how to work with them inside of 2D, we're going to jump over to a 3D environment and look at how we can basically create our games inside of a 3D world. So we're going to be looking at 3D models, we're going to be looking at applying materials to those models, as well as lighting, okay? All the fundamentals you need for creating 3D games. And then we are going to jump into scripting. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses, for people who are just starting out, or for people who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with the included course files. Alright, now let's get started with the first lesson. Welcome everyone. In this lesson, we are going to be looking at installing the Godot game engine. So here I am on godotengine.org. This is Godot's website and is where you want to go if you want to download the engine. So here I am on the homepage, and all I'm going to do is go down to where we have this download latest button right here, okay? Because we want the latest version of Godot, which comes with all of the cool new features and bug fixes, okay? So we do want to be up to date with that. So I'm going to click on download latest right here, and that is going to take us over to our downloads page. And as you can see here, it says download Godot for Windows. Now I am using Windows, but if you are using Mac or Linux, it should say Mac or Linux right here. Then what we can do is click on the blue Godot engine button right here, and that should begin the download of the files. Now, the good thing about Godot is that it is a very lightweight engine. Compared to many of the others out there on the market, Godot is only really around 50 to 100 megabytes in size. So as you can see, my download is pretty much complete right now, and it is very portable as well, okay? You don't have to download and install a bunch of files into your hard drive and all of that. Rather, it is just one simple executable that you can click and drag to anywhere on your computer. If you want to store it on a USB and launch Godot from there, you can easily do that. So now that the file has finished downloading, we can click on it and open it up. Now, this opens up in a zip file, and basically what we have here are two different executables. We have the main engine right here, which is around 100 megabytes in size, and the console. Now, with Godot, we don't really need to worry about the console right here. So what I'm going to do is I'm just going to click and drag on the main executable right here and drag it out to extract it. Now, I recommend storing this somewhere such as your documents, and you can of course then create a shortcut to open it up, or you can just open up the executable by double clicking on it, which we can do right now. So if I double click on this executable, it is going to open up the Godot project manager right here. And if you get a pop-up like this, we can just click cancel because we don't want to worry about, importing any projects just yet. So here we are in the Godot engine project manager. Now, this isn't the program where we're going to be creating our games. Rather, the project manager is in charge of managing our projects. Basically, it lists out all of the different projects that we've created on our computer, as of course you will be creating many in the future for all your different game ideas. And this is where we can, first of all, create new projects, open up existing projects, check to see which versions and manage version control, as well as removing projects if we no longer need them, okay? This is just a nice little piece of software which centralizes all of our different Godot games. So, in the next lesson, what we are going to do is work on setting up our first Godot project and opening it up. So, thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be working on setting up our first Godot project. So here I am inside of the Godot Engine Project Manager, and if you don't have this window open, then all you need to do is find your Godot executable, double click on it, and that should open up the project manager right here. Okay, now this is a program which basically allows us to create new Godot projects. It allows us to basically open up other ones, delete them if we no longer need them. It's just a way of centralizing all of our different Godot projects. So, how do we create a new one? Well, first of all, we want to go to the top right corner of the window and click on the New Project button right here. This is going to open up another window right here, which allows us to set up a few things. First of all, we can create a project name. And for this, what I'm going to do is I'm just going to call this, let's just call this Intro to Godot. And then next, we need to choose our project path. And this is going to determine where our project files are going to be stored. Now, by default, it should be in your documents folder, which generally is probably a good place. But if you wish, you might also want to go ahead and create your own dedicated folder for your Godot projects. So you can go ahead and do that by clicking on Browse and then navigating to the respective folder, okay? But for me, I'm going to store it here in Documents, and then we can click just above here where it says Create Folder. And what that's going to do is create a brand new folder in Documents called Intro to Godot. So we can click that. There we go. And now it should have a green tick saying that we are allowed to save it here. And apart from that, we can click Create and Edit. And what that's going to do is it's going to close down the project manager and open up the Godot engine. And here we are inside of the Godot engine, okay? As you can see, there are a lot of different buttons and text labels and things that may be a bit confusing to start off with, but in the next lesson, we are going to be looking at what each of these different windows do, what the buttons do, and how we can navigate around the engine. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be looking at exploring and understanding the Godot editor. So when we went ahead and created our project, we have this window which opens up, and this is where we are going to spend all of our time making our game, writing our code, and testing it out. So it's a good idea to get an understanding of what this piece of software is, how we can navigate around it, and what each of these things on screen do. So first of all, Godot, the main chunk of what you can see right now is separated into a bunch of different windows, okay? You can see here that we have these different rectangles which are snapping together. And if we click and drag on the lines between the windows, we can resize them. As you can see here, we just click and drag between these two windows to resize them. And this allows us to basically rearrange and resize the different elements to fit your needs and to fit your preferences. Now, what do these different windows actually do? Well, first of all, down here in the bottom left, you can see that we have a little tab that says File System. Now, the file system is basically like your file explorer on your computer, and this basically allows us to see all of the different folders and files that make up our project. So when we start writing down code or importing 3D models, textures, audio files, those get stored down here in the file system, and it allows us to create subfolders to store them in and just organize our project. You can see we have one file right here, which is called icon.svg, and this is pretty much just the icon for our game by default, okay? Now, we will get into the file system a bit more once we start actually creating some files, creating some scenes, but right now, as you can see, it's pretty empty. Now, over here in the center of the screen, this is probably the most prominent window, and this is basically a look into our game. This is where we can basically see into our game world. This is where we can construct our levels. This is where we can construct our player scenes and everything else. And we will get a better understanding of this once we actually start creating our game. Now, as you can see right now, it has a 3D view, okay? We can see the distance right here, we can see our vanishing lines, but Godot is a 3D and a 2D engine. And you can see that at the top here, we have these 4 buttons right here with 3D highlighted. Now, if we want to switch over to 2D mode, we can just click on 2D right here, and that is going to swap this center window over to a 2D perspective. We can go back to 3D. We can even click on script right here, and that will change the middle window over into our script editor. And this is where we can basically write down our code. Now, we're not going to be focusing on code at the moment, so we can just ignore this for now and go back to, let's just say 2D, okay? Now, here in our 2D, what we can do is then go over to the scene window. And the scene window right here is basically a list of all the nodes that make up our game. Now, the way Godot works is with nodes, okay? You can think of pretty much everything as a node, and a node can have children nodes, and those nodes can have children nodes in of themselves. We are going to be looking at what nodes are and how they interact with each other in a future lesson, but right now, just know that everything in your game is made up of nodes. And what that means is at the top, there needs to be a root node. And as you can see here, it says create root node. We can create a 2D scene, a 3D scene, a user interface, or other. Now, this is a 2D scene we're working with right now. So I'm going to click on 2D scene right here, and that is going to create ourselves a node. Now, you'll see if I select this node, over here on the right hand side in the inspector window, we have this information appear, okay? So I can click anywhere else to deselect it, and if I select the node 2D, it appears with information right here. Now, the inspector is basically like looking into whatever node we have currently selected. So if we were to select, for example, a player node, then we would see all of the player's information, such as its position, its stats, and any of the other properties that we might want to modify with it. So you can see on our node 2D right here, we have a bunch of these little drop-down tabs that we can look into, such as transform, which gives us our position, rotation, scale, and depending on the node, it's going to have different properties, such as a sprite node is going to have the ability to assign a texture, a mesh instance node is going to have the ability to assign a 3D model, and etc. So for right now, just know that on the left-hand side here in the scene window is where we have a list of all of our nodes. And if we select a node in the inspector, that is where we can actually modify its properties. And if it is a node that has a visual aspect to it, such as a player, an enemy, a tile, etc., it is also going to appear here in the middle in this scene viewport window. Now, how do we actually play our game? Well, at the top right corner here of our screen, you'll see we have a few different buttons. First up, we have the play button. Now, if we click on that, it's going to ask us to confirm our default scene. So we'll just go select current, and it's going to ask us to save our scene first. And I'm just going to save this as our test scene, hit save, and it's going to launch up our game window right here. Now, this is pretty much a window which is going to be our game as it is. Now, to get out of this, we can just click on the X on this window, or we can click on the stop button at the top right corner of the editor, and that's going to close that out. Now, down here in the file system, you'll see that we have added a new file to our file system, and that is our testscene.tscn, okay? Now, we're going to get into scenes in a future lesson as well as nodes, But for now, just know that a scene is basically a collection of nodes. Apart from that, we also have the output right here at the bottom. So when we press play on our game, the output opened up. And this is basically a window which can relay error messages or warnings that we might want to be aware of, okay? So if there's some problem in our game, the output right here is going to open up and it is going to display in red, what problem has occurred. So that is a quick overview of the Godot engine editor right here. As well, we also have some menu buttons at the top here. So scene, we can choose to create a new scene. We can open a scene. We can save the current scene we are in. Project, we have our project settings button right here, which opens up this window. And this is where you can manage a lot of the background settings for your project, such as the name, how big you want the window to be, some rendering and texture settings that you might want to get into a bit later on. So yeah, project settings is an important window, but we're not going to be focusing on it just yet. In the next lesson, we are going to be looking at understanding what is a node and what is a scene, because those are two vitally important things for understanding how the Godot engine works. So thanks for watching, and I'll see you all then. Hey everyone, and welcome back. In this lesson, we are going to be looking at how we can navigate around our scene in the Godot engine. So in the center here, we have our main scene viewport, and this is basically like a window into our game, okay? Looking at our environment, and it allows us to basically create stuff, drag stuff in, move stuff around. But how do we ourselves navigate this environment? Well, in 2D mode right here, all we need to do is hold down middle mouse and drag, okay? And as you can see, we can middle mouse and drag to basically pan around this screen. Now, there's not a lot to look at, but you can see we have these lines right here, and we can easily pan around like so. And if we want to zoom in, we can just use the scroll wheel and to zoom in, and scroll down to zoom out, okay? Now, what about if we are in 3D? Well, let's hop over to 3D at the top here by clicking on the 3D button. That's going to swap us over into this 3D environment right here. And we can hold middle mouse, and as you can see, if I hold middle mouse and move my mouse around, it sort of rotates around the center, okay? We are orbiting around whatever we are currently focused on. And if I hold down right mouse, our camera switches into this sort of first-person perspective where we can look around as if we are playing a first-person game. And as long as I am holding right mouse button, I can then use the W, A, S, and D keys to fly around, okay, as you can see right here. We can use E to go up, Q to go down, and fly like so. So, thanks for watching, and I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to be looking at how we can import some assets that we are going to be using throughout the course. So an asset is basically a file which we can use in our game, okay? Anything from textures to 3D models, audio clips, sound effects, scripts, any file that we can store on our computer and use in our game. Now, for this project, we are going to be using a couple sprites, which are basically 2D textures that we are going to be using for 2D games. So in the course files tab of this course, there should be a zip file which contains the assets needed for this course. So go ahead, download that, and then when you open up that zip file, you just want to extract the contents, and you should then have a folder called sprites, okay? And inside of sprites, you should have a player sprite and a coin sprite. Now, what we are going to do is we are going to go over into Godot right here, go down to the file system, we are going to right click, we are going to go new folder, and we're going to create a new folder called, we'll call this one out sprites, okay? Hit enter, and as you can see, here we have a brand new folder. Now what we can do is import our assets and store them inside of sprites right here. So I'm going to open up that folder once again, which contains my coin and player, and I'm just going to click and drag into the sprites folder like so. And as you can see, we can then open it up and we have our player sprite. Let's do the same thing for the coin. There we go. So now in our file system here, we have a sprites folder which contains coin and player. And the process for importing other assets such as audio files, 3D models, textures, it works in the exact same way. Okay, you just need to click and drag into your file system, and then those assets are going to be stored in your project files and pretty much ready for you to use. Hey everyone, in this lesson, we are going to be looking at the concept of nodes and scenes inside of Godot. Now, it's important to note that everything in your Godot project, in your Godot game, is made up of nodes, okay? Your player, your enemies, your environment, your lights, your backgrounds, your camera, everything that can have a position in space or that can contain some sort of logic behind it is made up of a node. And nodes can have children nodes, which can have children nodes. So pretty much Godot is based off a hierarchy of nodes. And we're going to look at how we can create those and how they work. So over in the scene window right now, you can see we already have a node which we created. And this is what's known as the root node. Okay, this is basically the upmost node in our scene, and this is going to contain everything else that we want to include in this scene right here. And you can think of a scene as a collection of nodes that can be instanced at any time. Okay, so for example, your levels, you might have a level 1, level 2, level 3. Each of those are going to be its own scene, which we are going to load in whenever we want to play them. But scenes can also extend to other sets of nodes that we might want to have repeated instances of, such as our player. We might want to have our player in level 1, in level 2, and that could be then a scene as well. The same goes for enemies, okay? You probably want to have dozens of enemies at once in your game, and the easy way to do that is by making one enemy, saving it as a scene, and then spawning that scene in multiple times. Okay, we'll have a better understanding of how this works in just a bit. Let's look at nodes. So we have our node 2D right here, which is our root node for this scene. If we select it, you'll see that over in the inspector, we can have a look inside of that node and view and modify its properties, okay, such as its transform position, rotation, and scale. Although for the root node, you don't really want to be modifying the position, rotation, or scale for this. Generally, with your root node, you just want to leave it as is, so we're not going to touch anything with that. But what we can do is also go ahead and create some new nodes. So let's click on the plus at the top left corner of our scene window, and that is going to open up the Create New Node window. Now, as you can see, there are a lot of different nodes here we can choose from, and if we go down to where it says Node 2D, we have a little drop-down arrow, which if we click, is going to show us all the different types of 2D nodes we can choose from. And down here we have node 3D, which shows us all of the 3D nodes that we can choose from as well, okay? And control is for UI elements like text, buttons, and on-screen images. But we're not going to look at that for now. Let's focus on the node 2D nodes. And you can tell they are 2D based on the fact that the icons are blue, okay? Now let's go ahead and create ourselves a node. Let's go down to where we have Sprite 2D. And as you can see, we have a little description down here, which is a general purpose sprite node. Let's click create. That's going to create a brand new node as a child of the root node. And that is the way this all works, okay? A node hierarchy. Nodes are going to have children, which basically inherit their position, rotation, and scale. And nodes can have pretty much as many children as they want. And even those children nodes can have children nodes of themselves, okay? It can get pretty complicated once you have big scenes. So we have our Sprite 2D right here. So at the moment it is called Sprite 2D, but let's rename it to something that's a bit easier to understand. So I'm going to double click on the sprite name, on the node name I mean, and we can then rename it to something such as player, okay? Now, you can also see what type of node a node is by looking at the icon, okay? So we have this little smiley face for the sprite node, or if you don't know the icon, you can go over to the inspector and have a look at what type of node it is right here. Now, this is a Sprite 2D node, which means it renders a sprite, and a sprite is essentially just a texture that we are rendering in our game. So what we can do is go over to the texture property of our sprite 2D node, and you see right here it says empty, and this means that we can assign a sprite. So I'm going to go down to my file system, and you'll see here that we have our player.png. Well, all I'm going to do is just click and drag that into the texture property right here, and when I let go, you'll see over in our scene viewport right here, we have our player texture, or our player sprite, rendering on screen. Okay, so we can zoom into that to have a better look, and there we go. So our player sprite is now rendering at this node right here. And if we go over into the transform property of our node 2D, you can see we can modify the position on the X and the Y axis. Okay, the X axis is horizontal and Y is vertical. You can think of it like a graph. So I can go to the X position here and change that property to, let's just say, 50. And as you can see, we are now 50 pixels to the right. If I go negative 150, we are now negative 150 pixels from the center of our root node. Okay, our root node is directly in the center of the graph right here, with our player being positioned relative to it. So we can even modify our Y position to be, let's just say 50, or we'll make it, let's just say 70. And there we go. Our player is now 70 pixels down and 150 pixels to the left. We can also modify our rotation if we want. Okay, this is in degrees, so you can do a full 360, but I'm just going to keep that at 0. And scale here modifies the size. So if I make this 2 on the X, you can see it is then 2 times as large. Let's bring that back down to 1. Okay, so now that we know how to create nodes, let's look at the idea of scenes. So right now in our test scene here, we have our player. Now let's just say we want to have, multiple different players in our scene, or enemies, or rocks, or trees, or anything that you want to have multiple instances of, yet are at their core the same thing. Well, what I'm going to do is select our player, go Control D to duplicate it, then we can go over into transform. Let's give it a position change of, we'll go negative 50. Oh no, we'll go negative 100. So the player is a bit to the left. And we have now created 2 player nodes. Now we can also go ahead and duplicate that again. And another way to duplicate is by just right clicking the node and going down to duplicate. Okay, we can then change that transform position to be, let's just say 100 on the Y. So now we have 3 players in our test scene. Okay, well, let's just say with our player, we want to change their color. How do we go about doing that? Well, we can select our player node. We can go down to the visibility drop down here and change where it says modulate. And modulate is basically a color multiplier. So we can then change our color here. Okay, we can just mess around with these settings here until we find a color that we like. There we go, like green. And then let's just say, we want all of our players to be the exact same, so let's go through and do the exact same thing to this other player here. Okay, we can change their color. And as you can see, it's going to take a bit of time if you have a lot of stuff. And you can also think of this as if you have, let's just say you have a 3D environment and you have a bunch of trees in your level, okay? And you want to basically make a change to all of those trees. Let's just say, the game's changed a bit and you want these trees to have more flowers, or you want these trees to be able to sway in the wind. Well, you'd have to go through every single tree node and apply those changes, okay? And that can take time depending on how many you have. If you have a bunch of collectibles in your game and you want to change the speed of the collectibles animation, that could take you a long time going through hundreds of collectibles. So a better way of doing this is by turning our player into a scene. So I'm going to go ahead and delete these other 2 player nodes right here. Let's bring that modulate color back to white so our player no longer is green. And what I'm going to do is I'm going to select our player node. I'm going to right click it and I'm going to go down to where it says save branch as scene. Okay, we're going to click that. We can then give our player scene a name. I'm going to call it player, hit save. And then down here in our file system, you'll see that we have a brand new file called player.tscn. Now, if I double click on that, that is going to open up a brand new scene window here. As you can see at the top, we have 2 tabs. We have test scene and we have player. And you can see that in our player scene, the root node is that sprite node. Now, what we can do is if we go back to our test scene here, we can drag our player.tscn from our file system into our test scene here. Okay, we can drag in a bunch of them if we wish. Now, let's do the same thing as before. Let's go ahead and change the player's color. Well, we could go ahead and change the visibility and all that, but instead what we are going to do is we are going to make a change to our player scene, okay? Because remember, all of these nodes right here are an instance of our player scene, okay? Everything that we change in our player scene gets applied to these nodes because they are basically a creation of the player scene blueprint. So if we go over to our player scene, what we can do, select that node, go down to visibility, go modulate. Let's change this color to, we'll make it a sort of a reddish pink color like so. And if we save it with Control S, go back to our test scene, you can see that every single player node is now this red color. And that is because their properties are inheriting from that player scene, okay? And with scenes, we could add a bunch of different nodes here. So if I right click on player, I can go add child node. And let's just say as a child of this player, we want another sprite. So I can go sprite 2D, find that in the list, create that. Let's set the texture this time to be coin, okay? And we might then want to go transform. We might want to move the coin, let's just say just above the player's head. So I'm just going to go -50. There we go. We got the coin above the player's head. And as you can see here, it is a child of player. So wherever player goes, this sprite will follow as well. We can save that, go back to our test scene. And as you can see, every instance of that player scene now has that change applied. Hey everyone, in this lesson, we are going to be looking at the different tools that we can use in order to move, rotate, and scale our nodes. Now, we already know that if we select a node, we can go over into the inspector, down to transform, and we can modify the position, rotation, and scale properties right here. But, you know, this can be a bit annoying if we're trying to specifically position something. We don't always know exactly where in the world we want to put it based on a number. So what we can also do then is with a node selected, we can go to the top left corner of our scene viewport and you see there are these 4 tools, okay? We have the select mode, we have the move mode, we have the rotate mode, and we have the scale mode, okay? Now we can select these tools by just left clicking on them. And if I click the select mode, what this means is I can select a node whenever I click on it. As you can see, I can click on a node and it becomes highlighted. Now, with the select tool, we can then select a node, and then we can go over to the move mode, for example, and you can see that it changes a bit. We have now this little gizmo on screen which has 2 arrows, a red arrow pointing to the right and a green arrow pointing down. This basically means that we can modify the position of this node. So if I click and drag on it now, as you can see, I am now basically moving it around. So I can move it over here, move it over here. And we can also use our keyboard shortcuts to navigate between these. So if we want to go back to the select mode, we can just press Q on our keyboard to select a node. We can then press W to go to the move tool and move it around. Now, as well as this, we also have the rotate mode, which is this third button right here with the keyboard shortcut of E. And basically this means if we click and drag on a node, we can then rotate it around like so, okay? And if we press S or go to the scale mode right here, we can click and drag to change the size of this sprite. And as you can see, we can click and drag on these individual boxes. So if I click and drag on the red one, it scales it along the x-axis. And if I click and drag along the green box, it scales along the y-axis. So let's just rotate that back into its normal orientation. Go back to the move tool, move that around a bit. And with the move tool, if you want to move it along a specific axis, you can just click and drag on these lines as well, okay? So I can click and drag on the red arrow to move it along specifically, move it specifically along the x-axis, or I can click and drag on the green arrow to move it specifically along the y-axis, okay? Just like that. So that is a look at the select, move, rotate, and scale tools inside of Godot. Okay, so as a bit of a challenge, this is what I want you to attempt. I want you to first of all create a brand new Sprite 2D node with the coin texture. Okay, we have those two textures, we have the player and the coin. And then I want you to duplicate, position, rotate, and scale those nodes in order to match the image on the right-hand side. So you can see over there we have 6 different nodes positioned, rotated, and scaled in a certain order like so. So that is your challenge. Have a go at that, and I'll be right back to see how you're done. Alright, so I hope you had a go at that challenge. Pretty much what we want to do is, let's just pan over here so we have a bit of room. We first of all want to create our Sprite 2D node. Now, in order to do that, we could go ahead, click on the plus, create the node here. But an easy way of doing that is, if you already know what sprite you're going to use, we can go down to the file system, click our coin.png and just drag that into our scene. And as you can see, it's going to automatically create a brand new Sprite 2D node. It's going to assign the texture and give it a name of coin, which is great. So what we want to do now is we pretty much want to select this coin, press W to go to the move tool, move it up here a bit, press Control D to duplicate that. We then want to move this one down a bit here, and then we want to then go Control D again, move this one over here to the right. We then want to press S to go to the scale tool. Now, as you can see, it's a bit hard to get the right scale, so it's even. So what we can do is hold down Shift, and that is going to scale uniformly along all axes. So we can scale this one down here a bit, go back to the move tool, move it over, Control D, move this one over here, Control D once again, move this over here. We can then scale this up a bit, and we can then press E for the rotate tool, and we can click and drag to rotate this around. Now, you might not be able to get a proper rotation on this, so once again, just like with scaling, we can hold down Control this time, and this sort of snaps the rotation, as you can see here. So we can get a nice square angle like that. We can then duplicate that once more and move it over here. And there we go. We now have our little structure of nodes here, which have each been moved, rotated, or scaled into the correct position for them. And that is the challenge complete. So I recommend that you do have a go continuing to learn the select, move, rotate, and scale tools, as you'll be using them all throughout your Godot projects, okay, to align certain colliders with sprites, to dragging and dropping in pretty much any piece of, or any scene or node structure that you want for your game, such as enemies, rocks, collectibles, eventually with UI elements as well. You'll need to be knowing these tools. So yeah, have a go at that. And in the next lesson, we are going to have a further look at parenting inside of Godot. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at the concept of parenting inside of the Godot engine. Now, we've already looked at parenting in the fact that we have created nodes. So whenever you create a node, unless it is the root node, which we have right here, then you are making a child node of another. Okay, so let's start by creating ourselves a node. So I'm going to go ahead, click on the plus, and I'm going to search for Sprite. There we go, create the Sprite 2D node. And now, as you can see in our scene window right here, Sprite 2D isn't in line with Node 2D, okay? Rather, it has a bit of a inline right here, denoting that it is a child node. And Node 2D even has a little drop-down button right here to toggle open and close its children nodes. So in your scene, everything is going to be a child of the root node, okay? Now, we can also have children of children nodes. So if I select the Sprite 2D right here, let's assign the player.png to the texture, okay? And what we can then do is we can attach another child node to this. So what we can do for that is right-click on Sprite 2D, go Add Child Node, and let's just say for this character, we want to give them a collider. Well, we can search for Collision Shape 2D. Let's create that. And as you can see, that is then indented as well into Sprite 2D. So now Collision Shape 2D is a child of Sprite 2D. So if I select the Collision Shape node, we can then go ahead to where it says Shape, click on the little drop down here, and then we can choose something like Rectangle Shape 2D. That's going to create a blue box right here, which we can then go ahead and click and drag on these little nodes to resize. Something like that. There we go. So now we have a sprite node which has a collider on it. And then what we can do is select our sprite 2D, and if I click and drag on these arrows here to move it around, go W to get to the move tool, we can move it around and you'll see that the collision shape follows along. Now, the reason why it is following along is because if your node is a child, it is going to inherit your properties such as your position, rotation, and scale. So if I then go to the rotate tool and I rotate this around, you can see that the collision shape 2D also rotates. And if I go to the scale tool, it also scales, okay? So that's the great thing about these children nodes. So if you have a player, for example, and you want the player to be holding onto an item, well, that item, as long as it is a child of the player node, it's going to follow that player along wherever it goes. And a good way of having a camera follow the player is by making the camera a child of the player. And that basically means that wherever your player goes, the camera is going to be locked on them. So yeah, that is just a quick look at creating or using parenting inside of Godot. And this is going to become second nature once you start creating all of your games and all of your different scenes. So thanks for watching. Hey everyone, so far in our Godot journey, we have been looking at 2D scenes and 2D nodes. Well, Godot is a very versatile engine and it actually allows us to also create 3D games. So how do we go about doing that? Well, let's go ahead and create a brand new scene for our 3D level. And to do this, we are just going to go to the top left where we have scene and we're going to go new scene. Okay, that's going to create a brand new scene here and we need to choose a root node. Now, when creating a 3D scene, you of course need to have a root node of 3D. So we'll click on 3D scene right here. And as you can see, it's going to switch us over into 3D mode and it's going to create a node 3D. So I'm going to go up to scene, save scene as, and I'm just going to call this one our, we'll go test scene 3D. There we go. So now we have our 3D environment right here. Now, once again, to navigate around this, we can hold right mouse to look around, use the WASD keys to fly, E to go up, Q to go down, and we can then middle mouse to sort of orbit around what we are focusing on. Okay, those are the basic controls for our 3D environment right here. Now, how do we actually create stuff? Well, in 2D Godot, we have sprites to pretty much show us, some sort of visual aspect. Whereas in 3D, we can create what's known as a mesh instance node. And a mesh instance node is a node that can render a 3D object. So I'm going to click on the plus to create a brand new node. And I am going to search for mesh instance 3D right here. Click create. That's going to create a new mesh instance node. We can then go over to our inspector. Now, if you already have a 3D model that you want to use, you can just drag that in. Although for us, we can click on the little drop down here and we can choose to create a brand new basic primitive mesh. So I'm going to click on new box mesh right here. And as you can see, that is going to create ourselves a brand new cube. But yeah, we have our cube here. And just like in 2D, we can go to our move tool and we can move it along by clicking and dragging on these arrows. But you will notice that in 3D, we don't just have the X and the Y axis, but we also have the Z axis, which is the blue one right here, okay? And that is because in 2D space, we only need 2 axes in order to denote a point in space, whereas in 3D, we need 3 values, okay? The X, Y, and Z. And if we go over to our transform, drop down here, where we have our position property, you can see we now have 3 boxes to fill each of those in. Now, it is also different, the unit of measurement from 2D to 3D. In 2D, we are measuring distances in terms of pixels. So, 100 pixels may only be like the width of your character, whereas in 3D, it uses meters. And as you can see, if I click and drag along on the red axis, you can see here in the transform property, the x-axis goes from 0 over here to 1 over here, okay? That is a 1 meter distance. And we can, of course, fill this in ourselves. So let's say we want to go 5 meters along the x-axis. That brings us all the way over here. 1 meter up, that's going to bring us up here. And let's just say -2 meters back on the z, that's going to bring us over here, okay? Now, you'll see on the move tool, we also have these little squares. And if we click and drag on those, that basically moves us along a specific plane, okay? So if we click on this green one, that's going to move us along pretty much every axis but the Y. If we click and drag on the red one, that's going to move us along the Y and the Z axis. And the blue one is going to move us along the X and the Y axis, okay? Now, what we can also then do is we can rotate as well. So if we press E, we go to the rotate tool, and it does look a bit different. So we have each of these different axes that we can rotate along, like so, or we can just click and drag in the middle of this sphere to rotate it along our current viewpoint. Okay, it should be pretty intuitive once you get actually working with these tools. And again, if we press R, we have our scale tool. We can scale along each of these individual axes like so. Or if we click and drag in the center, we can scale along all of these axes. So yeah, that is a quick look at the tools that we use for 3D. Again, they're pretty much the same as 2D, yet with an extra axis added on top, okay? Because again, we are working in 3D space. Okay, so as a bit of a challenge, this is what I want you to do. I want you to go ahead and create a snowman using multiple mesh instance 3D nodes, okay, like on the image on the right hand side here. And for this, you're going to be using the selection, move, rotate, and scale tools, okay? So have a look at that image on the right, see what you need to do, and then go ahead and attempt it. And I'll be right back to see how you're done. Welcome back, everyone. I hope you had a go at that challenge. So let's look at how we can accomplish it. First of all, we need to create a mesh instance node. So I'm going to click on the plus, search for mesh instance 3D. There we go. Let's create that now. And we can then go over to the inspector, go to the mesh property, click on the little drop down arrow, and we are going to go down to where we have new sphere mesh. Okay, create that just like so. We can then go Control D to duplicate it. Using the move tool, we can move up. We can then scale this down. We can then duplicate that again, and then scale that down for the head. Now for the arms, what we can do is I'm just going to duplicate one of these mesh instance nodes, and then we can go over to mesh and change that to a box mesh, okay? Move that up. We then want to scale, so we have nice thin arms, but we want to make them long, like so. And there we go. That is how we can make a snowman using these mesh instance nodes. Now, as a bonus, what we can also do is make it so that these are all the child of its own separate nodes. So if we want to make multiple instances of these snowmen, we don't have to select all three or four of these mesh instances in order to do so. And the way we can do that is by creating a brand new node 3D. Okay, create that. Let's double click on it. Let's call this one snow. And we can then select our mesh instances and drag those in as a child of snow. So pretty much click and drag on a node and hover over another to make it a child. Now, if I click on snow here, you can see everything gets selected and I can then move it like so, okay? We can even go to the scale tool, scale everything up or down, even rotate everything around as well. So you can see, just like I mentioned before in 2D, every single positional, rotational, and scaling change we make to the parent node also gets applied to the children, okay? So we can move them around as one whole. Welcome back, everyone. In this lesson, we are going to be looking at materials inside of Godot. Now, first up, what is a material? Well, in 3D rendering, a material is basically a file which tells our computer what we want an object to look like, how we want something to be rendered to our screen. Okay? Now, in fact, we're already using materials right now. These mesh instances right here have a default material on them, okay? It's nothing special, nothing flashy, but it is, as you can see here, casting shadows. It is detecting where the light is coming from and rendering it to our screen with the correct shading. So we already have a material here, but you probably don't want your things to look like this. You probably want them to have a bit more color, maybe even some texture. So what we're going to do is create a material. So let's go down to our file system here. I'm going to right click and create a new folder called materials. And then inside of this materials folder, we want to create a new material. And to do that, we can right click, go new, and then resource. Now, a resource is pretty much what Godot calls their assets, okay? And as you can see, there are a bunch of different resources that we can create. So I'm going to search for material, okay? And you can see here, there are a bunch of different materials. So what we want to do is go down to where we have a standard material 3D, okay? And this basically allows us to do what we want. So click create. We need to give it a name. I'm just going to call this one our test material since we are going to be changing a few things around on it. Hit save. And if we open up our materials folder, you'll see that we have a test material.tres, okay? And there it is. Now, if I select this test material, you'll see that over in the inspector, we all of a sudden have a bunch of different settings, okay? Transparency, shading, vertex color, albedo. We have all these things to modify for this material. So there are a lot of things that you can change about it, such as the texture, the roughness, the shininess, the color, the transparency. And I'll give you the opportunity to go through and do that yourselves, as there are plenty of different things to change. But for us, we are just going to change the albedo, which is the color of the material. So I'm going to open up the albedo drop down here. I'm going to select the color property, and we can then go ahead and change this to something. Let's just say we want to make it green. Now, if you're having a bit of trouble selecting the color that you're trying to get, you can go over to where we have the HSV, and I think this is probably my favorite color picker. So we can choose the hue, choose our saturation, and then our vibrance. Okay, so I'm going to choose let's just say a greenish color. Whoops, greenish color right there. There we go, a nice vibrant green. As you can see, we have this little preview window which shows us our changes. We could even go down to roughness and change the roughness value. And if I drag that down, you can see it gets really shiny, because if something is not rough at all, then it is smooth. Thus, it's going to reflect a lot of stuff. So let's bring that roughness down to around 0.2, so we have nice specular highlights. All right, now how do we actually apply this to our mesh? Well, what we can do is just click and drag on the material and hover over the mesh that we want to apply it to. So we can click and drag on our head, our body, our legs, and our arms, and there we go. And as you can see, we now have this material applied, and automatically it makes our snowman look quite a bit different, okay? We have a more soft, I'd say reflective, plasticky looking substance than we had before, and we can even select our material and change these properties live. So let's say we want to bump up the roughness to make it look more of a matte color. We can bring the roughness all the way down, so it is now pretty much reflective, but you can't really see the reflectiveness that much here, so bring the roughness up a tiny bit. Go to metallic, we can change the metallic value, and as you can see, if I bring that all the way up, it pretty much looks like it is a nice shiny steel ball, but I'm going to bring that down a bit here. And yeah, have fun just going through changing these different things. We even have rim, which is going to give us a Fresnel effect on the outside of our thing here, as you can see. So yeah. Okay, so as a bit of a challenge, this is what I want you to do. Below, we have these three materials that I've gone ahead and created, and I want you to try and replicate them. Now, the one on the left is probably one, that we've seen so far. We have an albedo, we have a high roughness. Then the one in the middle is using transparency. So I want you to explore and experiment with the transparency settings of the materials. And then on the right-hand side, we are assigning a texture to this material. So I want you to go ahead and try and replicate these three. And in the next lesson, we're going to go over how we can accomplish those. So thanks for watching, and have a go at the challenge. Alright, so I hope you had a go at that challenge. Pretty much what we want to do is first of all create our three spheres. So I'm going to go ahead, create a mesh instance 3D here, assign that mesh to be a new sphere. We can then duplicate that and make two more on either side. There we go. So now that we have our spheres, we then need to create materials for them. So inside of our materials folder, I'm going to right click on it, go new, resource. I'm going to go down to where we have standard material 3D, and I'm going to call this one pink ball. Okay. Now for our pink ball, we can click and drag on that sphere. As you can see, it doesn't really change much since the default material is very similar to the one that gets assigned when we actually create the mesh. But we can click and drag it on. We can then go over to the inspector, change the albedo color here. I'm going to make that a nice vibrant pink, something like that. And we can then change the roughness. Actually, no, keep the roughness at 1. I think that's going to be a good idea. There we go. Now we can move on to the second ball, and this is going to be transparency. So I'm going to right click on materials folder, go new, resource, standard material 3D. I'm going to call this one blue transparent. Okay. Or technically translucent. So I'm going to click and drag on the center one here. We can then go in the inspector down to albedo. Let's just give our ball its blue color real quick. There we go. And then we can go over to the transparency drop down here. And right now transparency is set to disabled, so we want to click on that drop down and change it to alpha. Now what we can do is go back to our albedo, open up that color again, and you'll see here we have our RGBA values, red, green, blue, and alpha. And alpha is basically transparency. So we can click on drag on that slider to bring that down in transparency, as you can see here. And now if we pan our camera around, we can actually see through our ball. Now with transparency, there are a bunch of different types of modes for transparency. So if I click on the transparency drop down again, you see we have alpha, alpha scissor, alpha hash. So if we go alpha hash, for example, you can see that it basically has this solid blue mixed with totally invisible, okay? So it gives the appearance of transparency. And depending on, the rendering situation, it may be better performance for your game to do it this way. But I'm going to switch that back to alpha. We also have our blend mode, which basically determines how it renders the transparency based on what is behind it. So if we go add, that means it's going to add this blue color to whatever it is behind. Subtract subtracts it. So as you can see, it has this weird looking effect right here. And multiply is multiplying the colors together. Okay, so that's going to make it a bit darker. But typically, mix is what you were looking for the blend mode. Now, for our final sphere, we are going to be applying a texture. So I'm going to right click on materials once again, go new, resource, standard material 3D, and I'm going to call this one our texture ball. Okay, click and drag on the sphere, and to apply a texture, what we need to do is go down to where we have albedo, and you'll see here we can of course change the color, but we can also assign a texture, and that is going to be the flat color texture for our ball. And for this, I'm just going to be using our player sprite, so we can just click and drag that in here, and there we go. So as you can see, we have our player right here. We can even click on the color property, and we can actually modify the color that is sort of being multiplied by the texture, okay? So if we want the texture to look more blue, we can do that. If we want to make it look more red, we can change it to red. Okay, and that is pretty much the basis of materials inside of Godot. Once again, there are a lot of different settings here for you to change, and I just hope that you go ahead and experiment with these, as you can create some pretty interesting looking materials for your games. So thanks for watching. Hey everyone, in this lesson we are going to be looking at lighting inside of the Godot engine. Okay, now when working in 3D, lighting is very important as it sets the mood and it sets the theme of your game. So how do we create lights inside of Godot? Well, first of all, let's get an actual mesh in here so we can see what effect it has on the actual environment. So I'm going to click on the plus, I'm going to create a new mesh instance 3D, and we can change that to be a sphere. Okay, there we go. So we've got our mesh here. Now let's go ahead and apply some lighting to it. Now, if we click on the plus and we search for light, you'll see there are 3 different types of lights we can create. We can create a directional light, an omni light, and a spotlight. Now let's start with directional light. So I'm going to select it and click create. Now, a directional light is basically like the sun, okay? Our sun shoots down rays of light parallel to each other, and that's essentially what a directional light does. It casts a light in a single direction. So if we go to the rotate tool here with the directional light selected, you can see that we have this white arrow pointing in the direction that the light is being shone from. And you can see we even have a little sun up here in the skybox to show where it's coming from. And you'll see on our sphere here, the left-hand side is being hit by that light. And if we rotate this directional light, you can see how it changes the actual source or the direction of that light. Now, good thing about directional light is that it can be moved around anywhere in the scene, but the position does not affect where the light is coming from because it's basically coming from an infinite distance away. It's only the rotation that really matters when it comes to the directional light, okay? So you can see here we can modify our directional light rotation to modify where on the sphere it is being hit with light. Now, something else we can do with the light is many things actually. If we go over to the inspector and open up the light drop down here, you'll see there are a bunch of different settings we can change. For example, the color is, as it sounds, it's the color of the light. So if, for example, it's nighttime, you might want to have a bit more of a coldish blue light, so something like this maybe. Whereas if it's daytime, you probably want a nice, vibrant, slightly yellow-hued light, okay? And you can go ahead and modify those for whatever you wish. The energy, this is basically the intensity of the light, okay? And as you can see, if I bump this up, our sphere starts to pretty much glow if we increase the energy there. Whereas if we put it at 0, it's as if there is no light. So I'm going to bring that back up to 1. We don't really need to worry about the rest of these settings here since they are all for light baking and a much more complex lighting, so we're just going to ignore those for now. Okay, so we have our directional light. Now, what about those other light types? Well, click on the plus, and let's create what's known as an OmniLight 3D. So we'll create our OmniLight, and with this, you'll see it has a sphere, okay, this wireframe sphere on the outside. And this basically is a light that emits from a single point in all directions, okay? You can think of it like a candle, a light bulb, okay? It has a source of the light, and it emits in all directions. So what we can do is we can press W to go to our move tool. Let's move this light over here, and as you can see, it is lighting up our sphere. And this white wireframe is basically the range of the light. We can click and drag on this little orange node right here to basically change the range of that light. Now, to make things a bit easier to see, I'm going to go ahead and create a new mesh instance 3D. Let's set this mesh to be a plane, and that's basically like a solid ground. Let's increase that scale. Move it down a bit. There we go. Okay, so we'll select the OmniLight again. We can move it around. To have a better viewing of it, to actually see what we are casting, let's change that light color over to, I'm going to change that over to we'll change it over to a red. Okay, we'll make a nice red light here. And we can then bump up the energy a bit, and we can then see how that affects our surroundings. Okay, now it might be a bit hard to see because of the white ground, so what we can do is select our directional light, and let's bring that energy down to 0, okay? So now it's pretty much just our OmniLight shining here. And you can see we can change all the settings, the energy. Now, to change the range, we can open up the Omni drop down here and change the range. We also got the attenuation, which is basically the fall-off curve. Now, with lighting, we also have shadows, and so how do we apply those? Well, let's first of all set the energy of our OmniLight down to 0 for now, because we'll look at our directional light. Let's bring that directional light back up to 1. Now, how do we cast a shadow on this sphere onto the plane below? Well, to do that, we want to open up the shadow drop down here and just enable it. And there we go. It's pretty much done just like that. Same thing for the OmniLight. If we bump up that energy, we can go down to shadow and enable that shadow as well. And you can see there is a bit of a shadow cast here. Now, it is important to note that shadows do have some performance cost, but you shouldn't worry about that unless you have quite a few of them in your scene. Now, finally, we have one more light, and I'm just going to delete our OmniLight here and delete our directional light. And that is going to be our, if we type in light, our Spotlight 3D. Now, Spotlight is pretty much as it sounds. It is a light that emits in a cone, okay? These would be good things for headlights, street lamps. If your character is holding a torch, a spotlight would be good for that. So I'm just going to rotate this spotlight so it's facing down, And you can see if we zoom out here that there is this white cone wireframe, which basically shows us the angle, which we can modify by clicking and dragging here, as well as the range. So we can modify those two things here. We can then change the light energy, so we might want to bump that up like so. We can change the color, so let's change this to be a, we'll change this over to be a green, for example. There we go. And of course, just like with those other lights, we can apply shadows as well, and there you go. So yeah, that is just a quick look at these different lighting systems that we can use inside of Godot. We have the directional light, which acts like a sun. We have an omni light, which acts as a light source that emits in all directions, like a candle or a light bulb. And then we have a spotlight, which emits in a cone, and that acts as if it's a torch or a street lamp. So I'd recommend having a go experimenting with all these different lights, as really there is a lot to learn when it comes to lighting, so have fun experimenting with that. Hey everyone, in this lesson we are going to be looking at scripting inside of the Godot engine. Now, scripting is a very powerful thing, and it basically allows us to write code which we can use to create whatever game we wish. So, first of all, what is scripting? Well, at its core, scripting is how we can create the gameplay behaviors and logic for our game, okay? And this is done via creating what's known as a script. And a script is essentially a file which we can create in the file system, okay? So it's an asset, and this is essentially just a text document which we fill with code. And then what we can do is we can attach that script to a node, okay? Each node at the bottom in the inspector, you may have already seen this, has a script property where we can assign a single script. And then that script can do certain things to that node, okay? For example, if we have a player, we'll want to attach a player script to the player's node, where it can then influence its position based on keyboard inputs. Or if you have some sort of enemy AI, you might want to attach that to the enemy. So let's hop over into Godot right now and look at how we can create a script. Okay, so the first thing we want to do is we want to pretty much figure out what node we want to attach our script to. Now, just for demonstrational purposes, I'm just going to select our root node right here, and I'm going to go over to the inspector, and you'll see here we have our script property, okay? And right now it is empty, meaning there is no script attached, so let's create one and attach it. Now to do this, we could right click in the file system and create it that way, or we can just click on the little drop down here next to the script property and go new script. That's going to open up this attach node script window, and this is where we can choose a bunch of different settings, but really for us, we just want to go down to where it says path. And this is where we can change the name of our script. So I'm just going to call this one intro to scripting.gd. Click create, and it is going to do two things. It's going to first of all create a brand new intro to scripting.gd file down here in our file system. And secondly, it's going to switch us over into the scripting screen, okay? Before we were in 2D, we also have 3D, and then it goes over to scripting, which is where we can write down our code. Now, there's a couple things already inside of the script editor right here. Some text, and pretty much just like Word or any other text editor, we can click around and we can type stuff in, okay? So it's pretty much a text editor, but specifically designed for the Godot scripting language, which is called GD script, okay? If you do have any prior knowledge with programming, then just know that GD script is very similar to Python, okay? But you don't need to know anything whatsoever about programming or coding in order to follow along with this course. We are going to go through everything from scratch. So you can see here that we have all of our code written down, which is just the default code it gives us right now. On the left-hand side, we have a list of all of the different scripts that we have, okay? So later on in your game, when you have, dozens of scripts, you'll probably want to be jumping between them to write code, edit stuff. So this is where that list will appear. And then down here, we have all of our methods, okay? Listing out our methods, and we'll get into what those are in a future lesson. And what differs this from just opening up Notepad or opening up any other word processor is because this piece of Godot is specifically designed for writing GD script. And that means we have what's known as code formatting. And that pretty much means that whenever we write down our code, you can see that certain things are different colors, okay? We have some pink stuff, some green, some purple, some blue, okay? It colors our code based on what we are writing, okay? Because the program knows what we are doing, okay? It knows the language we are trying to write in, and it colors the code based on that. And that just makes it a lot easier to look at and identify certain things. As well, typically these sort of programs also have autocorrect, okay? Which basically means that when you're writing down code, it tries to estimate and assume what you want to do, and it will pop up with a window with a bunch of different things. So if you're not quite sure on what a certain thing was called in the language, you can begin typing it, and a box will appear, and it might have your answer right there, okay? So we'll get into all of that later on, but for now, we have our script here inside of Godot ready to be edited, okay? So we can save this, and in the next lesson, we are going to be going over the concept of variables. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be learning about variables. Now, first of all, what is a variable? Well, basically, a variable is a piece of data which we can define, read, and change the value of, okay? It's basically this piece of data that we save to memory, and we have the ability to utilize it. Now, you can think of it like a box, okay? We can give a variable a name and assign it a value, okay? And at any time, we can try and find the box that, might say player's health, and inside of that, we have a value, a number, for example, and we can look at that number so we know what it is. We can also change it, add to it, subtract it, multiply it, pretty much anything we want to do with it, okay? And there are also different types of variables, okay? There are whole numbers, decimal numbers, text. There are a bunch of different variable types that we will be going over. So let's hop over into Godot and have a look at how we can start creating some variables. Okay, so here we are inside of our script. Now, the first thing we want to do is go to the right location to start creating our variables, okay? Now, you'll see we have this extends node 2D line of code right here. Pretty much, we just want to go to a line or a couple lines underneath it, okay? And what we are going to do is we are going to create a variable. Now, let's just say we want to create a variable that keeps track of a player's score, okay? Well, to do that, we have to define the variable. Now, to define a variable, we first of all have to write down the keyword var for variable, add a space. We need to give the variable a name, so I'm going to write down score, and then we can go equals and give it a value. Now, let's say score equals 0 by default, okay? And there we go. Var score equals 0. Var, which is the keyword which defines a variable, score, which is what we are calling our variable, equals 0, okay? We are assigning it a value of 0. So we've created a variable. Now, what do we do with it? Well, for right now, let's just print it to the output so we can actually see what it is. Now, printing basically means we are logging a message to the output down here, okay? You see at the bottom left here, we have the output. We can click on that, and that's going to open up the console, the output. And pretty much we can log messages here. Whenever we get errors in our code, that is where they'll appear as well. So you probably want to have this open most of the time when you're starting out, as it's very handy in catching all the little errors that you might write down. So how do we print our score variable down here to the output? Well, we want to go down to this thing right here where it says func ready, okay? And this here is basically what's known as a function. We're going to get into what functions are a bit in the future, but right now just know that a function is a block of code that can be called at any time. And the ready function gets called right at the start of the game to initialize stuff. So what we can do is remove this line of code where it says pass and write down print in 2 brackets score, okay? Now what this is going to do is it is going to print, and then in between these 2 brackets here, we want to basically add in what we want to print, in our case, score. So Control S to save, and then press the play button, and let's see what happens. Okay, I press play, and if we look over here in the output, we can see the number 0. Now we can stop playing that. We can then change score, for example, to be 5. Let's save that, press play, and down here in the output, as you can see, out it prints 5, which is great. Okay, so we have the ability to create variables and print them out. Now, we also need to go over the concept of variable types. Now, the way Godot is, or the way GDScript, is that it is what's known as a dynamic language, meaning we don't have to hard define specifically what we are doing and what we want. And that allows us a lot of flexibility, but generally, I'd say it's best practice, especially early on, to define the data types of your variables. And by that, I mean, when we create a variable, we need to basically tell it what type of variable it is going to be. So in our case, we have score, and score is a number. In our case, it's going to be a whole number, 1, 2, 3, 4, 5, etc. So what I'm going to do is after where we write down score, I'm going to add a colon, go space, and then write down the word int, okay, for integer. And that is a type of variable. An integer is a whole number. So this basically means that we are just defining score as being a variable that is a whole number. Now, what about other variable types? Well, let's go down to a new line here, create another variable, and this time we are going to create a variable of type float, which is a floating point number. So something that may have a decimal number in it might be the player's move speed. So I can write move speed colon float equals, and then we can say like 2.53, okay? There we go. So an integer is a whole number, a float is a decimal number. Now, you see here how I've written my variables, okay? They're all lowercase, and they have a underscore wherever there would be a space, because in programming, spaces are a big no-no, okay? If you're trying to make a name for something, you cannot have a space, otherwise that will cause an error, okay? So in variable here, we need to give it an underscore or just have no space at all. And this type of code formatting is known as snake case, and it's generally considered the general practice when it comes to GDScript. Everything here lowercase with underscores where you would put spaces. You can see here with the ready function, we have an underscore there and a underscore for the process function, okay? It's all lowercase. Now, as well as move speed, we also have another variable type, which is a boolean. And a boolean is a variable that has either two options, true or false. So I can create a variable here called game over of type bool, and this can be equal to true, okay? There we go. So game over, it's going to be true, or it can be false. So true or false for a boolean, and it's very good for those things where you want an on and off state, for example. So game over is a good one. Maybe if you want to keep track of if the player has something equipped, you could have a boolean for that. And then finally, one more data type we're going to look at is a string, okay? And a string is text. Now, the way we create a string is a bit different. We have to go var, we'll just call this one ability of type string with a capital S this time. And this is going to be equal to, and we need to put 2 double quotation marks, and we can just put in here slash or some sort of ability, okay? And there we go. So the way we define a string is by using the string data type, but this one has a capital S, okay, unlike bool, float, and int. And to write down a string value, we need to put it in these quotation marks, and you can see that with our formatting, it has turned it into this sort of brownish gold color, okay, to denote that this is a string. Now, a cool thing about variables is that not only can we read them, we can also modify their values. So down here in the ready function, we're printing out score. Let's go ahead and print out move speed, okay, just so we can see what it looks like. So we can then press play, and you'll see down here in the output, we have 2.53, okay, so that's all working fine. Well, what we can do is we can change move speed. So let's say just before we want to print it, so we'll go to a new line here, we can go move speed equals, and then we can change that to something like 5.1, okay? So now, if we save that and press play, we should see 5.1 in the output because we are changing it. And that's something else that I need to go over, and that is the order of execution, okay? When it comes to pretty much every coding language, there is what's known as an order of execution. And that basically means that it runs one command at a time, okay? In our case, lines. So when the ready function gets called, it looks at its contents and it runs it from the top down, okay? So it goes move speed equals 5.1, then it prints it out. And what we can do then is also go move speed equals 500.156, and then we can print that value out as well, okay? So what do you think this is going to look like when we press play? Okay, we're going to have two things printed out, and if I press play, as you can see, 5.1, 500.5 or 0.156, okay? And that is because we are, first of all, setting move speed to equal 5.1. We are printing that value out. We are then changing move speed to equal this new number, and then we are printing it out. Welcome back, everyone. In this lesson, we are going to continue on with creating variables, okay? So in the previous lesson, we looked at how we can define variables up here and give them a data type, okay? A data type is basically telling the variable what type of value it can hold. In our case, for score, it is of type int, which is an integer, and that means it can hold whole numbers, okay? 1, 2, 3, 4, 1,000, 10,000, 200, okay? Then we have move speed, which is a variable that is of type float. And a float is a decimal number, okay? This can be much more precise in terms of what numbers you can store. Then we have game over, which is of type boolean, or bool, we write here. And that is basically a variable which can be true or false, okay? On or off. And then finally, we have looked at a string variable, which is basically text, okay? And we define the value by putting it in quotation marks right here. And then down here in the ready function, which gets called right at the start of the game, you can even see there's a little comment up here which explains what the ready function does. We are basically assigning move speed to equal a new value. We are printing that new value out to the output window here. We are then changing the move speed again and printing the new value out to the output. And we also looked over the idea of order of execution, which basically means that since we are working with a computer, it has to execute one thing at a time, okay? And in our case with programming, it goes line by line. So when the ready function here gets called at the start of the game, it is first of all calling this line of code, then this line of code, then this line of code, then this line of code, okay? It goes down. And that is a core concept that you do need to keep in mind when writing your code. Now, let's remove this here, and let's look at, for example, how can we change some of these other variables. So let's say we want to change game over, okay? Let's just say something happens and the game is suddenly over. Well, we can go game over equals true, okay? And that is going to change that value from false to true. We can then print that out. So game over like so, save it, press play, and down here in the output, you can see it says true, all right? Now, we can also do the same thing for strings, okay? And to change a string variable, it's pretty much the same as everything else. We just need to go ability equals, and then in two double quotation marks, we can enter in a new string for this variable. And for this new string, let's just say we want to go heal, okay? A heal ability. And there we go. So we can then go to a new line, print out the ability variable, save that, press play, and there we go. It says true and heal. Okay, so as a bit of a challenge, I want you to go ahead and create 4 variables which are going to be used to define a country, okay? And each of these variables should be using a different data type, okay? And the 4 variables that you need to create is going to be a country name, a population, a highest altitude, and whether or not that country is landlocked, okay? Does that country have access to the sea? So each of those variables need to have a different data type, and then I also want you to go ahead and print all of these 4 variables out inside of the ready function so that when we press play, we can see them in the output. So have a go at that, and I'll be right back to see how you're done. Alright, so I hope you had to go at that challenge. Pretty much what we want to do is we first of all want to create our country name variable, and that is of course going to be done by using a string. So I'm going to go var, then I'm going to go country name of type string, capital S, equals, and for me I'm going to do Australia, so I'll write down Australia inside of the string variable here, alright? Now, next up, we need our country's population. and a population, that is a whole number, so that's going to be an integer. So I'm going to go var population of type int equals, and we're going to put about 25 million. 123, 123, okay? And then next up, we have the highest altitude. Now, this is going to be a variable of type float, okay? Because when it comes to measurements, you can get very fine with those, so it's probably good to have that as a floating point number. So I'm going to go var highest altitude of type float equals, and with the highest altitude, this here is going to be 2.228 kilometers, okay? Like so. Then what we need to do is have a variable for whether or not this country is landlocked. And since that is either yes or no, we are going to use a boolean for true or false. So var landlocked bool equals false. Okay, and there we go. So these are our variables that we have created. Now the next step is to go down into our ready function here, and we need to basically print each of these out. Now, the pass that is here by default, this is basically just a filler for the function, okay? If your function is empty, pass basically just is there to give it some body. So we can remove that, and we can go print country name. We can then go print population, print highest altitude, and then finally print landlocked, okay? Save that, press play, and we should see in the output here, we have all of those variables logging to the output, which is great. Okay, so we have all that set up. Now, in the next lesson, we are going to look at how we can start modifying our variables in different ways, and that is going to be done via operators. So thanks for watching, and I'll see you all then. Congratulations on completing the course. We just finished looking at the fundamentals of the Godot game engine. So let's have a look at what we learned throughout this course. First of all, we learned about the Godot editor. We spent some time installing the engine, creating our first project, and then having a look at what each of the different windows do and how we can navigate around. We then looked at the fundamentals of the engine, that being nodes, scenes, and the tools we can use to move those nodes and scenes around, as well as how we can do all of this inside of a 2D environment. Okay, we looked at parenting to get an overall understanding of how this engine works at its core, okay, with the fact that nodes are the fundamentals of pretty much everything in your game. We then took that knowledge and transferred it over to 3D, where we looked at creating models, applying materials to those models, and seeing what each material can do differently from one another, as well as lighting. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses, for people who are just starting out, or for people who are just wanting to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with the included course files. So thank you very much for following along with the course, and I wish you the best of luck with your future Godot games. Hey everyone, in this lesson we are going to begin looking at our physics project. Now, this mini project is where we are going to be learning about Godot's physics system, okay? And it is going to be a little game involving a player that we can push around with the mouse cursor and watch as it interacts and bounces around a bunch of different cubes, okay? So let's hop over into Godot and have a look at how we can set this up. So first of all, we need to create ourselves a brand new scene. So I'm going to go scene, new scene. And this is going to be a 2D project, so we are going to set the root node to be a 2D scene, and we are then going to rename this node to be main, since I like making my root nodes called to main, and then we are going to save the scene. Now, we are going to save this. We're going to be creating a new folder, so let's, before we do that, go down to our file system, right-click, new folder, and call this one physics, okay? We can then save our scene, save it to that physics folder. So we want to go up in the path, select the physics folder, open that up, and rename this to be our physics.tscn. Hit save, and here we are. Now, the first thing we need to do is create ourselves our player. Now, included with this course in the course files tab is a downloadable zip file which contains all of the assets you'll need for this course, although you can use your own sprites if you wish. So when you download and extract the contents of that folder, you should have two folders here, loops project and physics project. Inside a physics project, you should have two sprites, a crate and a physics character. We are going to select those and drag them down into that physics folder inside of our file system, okay? So we'll select those, drag them into physics. There we go. Now what we're going to do is we are going to create our player. Now our player is not going to be an area 2D or a character body 2D. Instead, it is going to be a rigid body 2D. So we can add a new node here, look for a rigid body 2D and create that. Now what is a rigid body 2D? Well, a rigid body is basically an object that can be affected by forces, it can collide with objects, it has friction, it has mass, inertia, and it's basically what you'd expect from a real-life object that interacts with the physical environment. So I'm going to rename the rigid body to be player, okay? So let's get our physics character sprite and drag that into our scene here, making that a child of player. I'm going to rename it to be sprite since I like naming my nodes pretty much exactly what they are and what they do. We'll set its position to be 0 on the X and 0 on the Y so that it is in the direct center of the rigid body. Now you may notice that the sprite is quite blurry, and that is because of the filtering mode for textures. So to fix this, we can go up to project settings, and then in project settings, we're going to go down to where we have textures. And where we have our default texture filter, we're going to change that from linear to nearest. And that basically means that instead of trying to blur the pixels together to make it look like a more concise image, it's going to render each pixel specifically. And there we go. Now, of course, this is only if you're using pixel art. If you're using higher res images, then you probably want to keep linear on. So now we also need a collider for our rigid body in order for it to actually work. Because if it doesn't have a collider, then it doesn't really serve a purpose. So we're going to right click on player, go add child node, and look for a collision shape 2D. We're going to set that shape to be a new rectangular shape, and we can then resize it to fit the bounds of that sprite. And there we go. So now that we have our player rigid body, what can it actually do? Well, let's see an action. So what I'm going to do is I'm going to go up to this button here, which is run current scene, or F6 is the shortcut. Press play, and as you can see, it's a bit hard to see, but our player actually fell with gravity. So before we continue, let's go ahead and add in a camera. So I'm going to create a new node of type camera 2D. There we go. And if we zoom out, we can actually see this purple outline, what it's rendering. Let's zoom it in a bit. So I'm going to set the zoom to be 2. So now we can press play and have a look and see if it works. So I'll press play, and there we go. And as you can see, it was pretty quick, but our character actually began falling down. And that is because they are being affected by gravity. Now, if we select our rigid body here, let's move it up a bit so we can actually see it a bit more. We'll press play again. And as you can see, there they go falling. Now, over here in the inspector, we can modify all of the different settings when it comes to a rigid body. Mass basically defines, how heavy an object is, and that will affect the amount of force that gets applied to it. If a lighter object, for example, hits into a heavy object, that heavy object isn't going to move as far if it is heavier than the light object, for example. We then have inertia, gravity scale, which defines how much gravity is being applied. We also have a bunch of other options as well that you can modify and change. You can add linear drag, you can add angular drag, you can add constant forces. There's a lot of stuff you can do with a rigid body 2D. So if I were to move the gravity scale down to about, let's just say 0, you'll notice that when I press play, nothing happens. It just stays there. And that's because it is no longer being affected by gravity. Now, how do we actually get our character to start moving around? Okay, well, to do this, what we're going to do is we are going to select our player. We're going to go down here in the inspector, and we are going to create a brand new script, which I'm going to call our physics player. Now, inside of this script, make sure that it is extending rigid body 2D, as we do need to access these specific properties. What we are going to do is delete the ready and process functions, since we won't be needing those, and we are going to create a variable called hit force of type float, and this is going to be equal to 50. Now, hit force is basically going to be the amount of force we are going to apply to our character whenever we click. Now, how are we going to detect a click? Well, in fact, we're actually going to use the process function, so let's go down here and recreate that. So func process, and with the delta parameter. Now we are going to check to see if our left mouse button is being pressed. And to do that, we can just go if input.is underscore mouse button pressed, mouse button underscore left. Then what we are going to do is we first of all need to get the direction that we want to move. And the direction is basically going to be the angle from our player here to wherever our mouse cursor is. So if I'm over here and I click, that's up, down here is down, right and left. Okay, so we basically want to find the direction vector and move in that, and basically hit ourselves in that direction. So to do this, I'm going to create a variable called dir for direction, and this is going to be equal to our global underscore position dot direction to, and that we want to get the direction to our get underscore global mouse position. Okay, so we are getting our position and we are calculating the direction to our mouse. What we can do then is call the apply underscore impulse function. We need to give it a vector, and this is just going to be our direction multiplied by hit force. So now if we save that and we press play again, you should see that whenever I click, our player goes moving in that direction, okay? But as you can see, they are flying all over the place and it's kind of hard to control. So what we need to do is apply some drag to our player. Otherwise, they'll keep moving on forever as if they were in, in space where there's no air resistance. So I'm going to select our player right here. We are going to go down to where we have linear, open that up, and here we can go to damp. And this basically damps our velocity over time, and I'm just going to set this here to be 1. And now if I press play, you'll see that whenever I move, we get hit and then we slow down, okay? And you can of course modify this as well if you wish. We can also change our mass, and I'll show you how that affects it. So if I change our mass to 5, we are all of a sudden going to be moving a lot slower. And the reason why is because if you have something that is weighing 1 kilo and something that's weighing 5 kilo, it's going to require a lot more force to push the thing that is 5 kilos compared to the thing that is 1 kilo. So that is just a look at how we have our mass and our damp, which affects quite a bit when it comes to our character controller here. Now, in fact, I'm actually going to zoom in this a little bit more just so we can get a better view. So if we go 2D here, select our camera, I'm going to bump this up to 4, press play. There we go. That's going to be a bit better, like so. Now, in the next lesson, we are going to be adding in our crates, which are also going to be physics objects, and we're going to be finishing off this little project right here. Welcome back, everyone. In this lesson, we are going to be finishing off our physics project right here, and to do that, we are going to be creating some crates that we are going to be moving around with our player. So to do this, I'm going to create a new node of type rigid body 2D once again. I'm going to rename this to be called crate, and this crate is going to have a sprite of the crate.png. We can make that a child of the crate, rename that to be sprite, set its position to 0 on the X and 0 on the Y, and then we can move this crate over here a bit. We then want to add on a collision shape 2D node. So collision shape 2D, we then want to give it a shape of rectangular, and we can then modify its bounds a bit so it fits correctly. And there we go. Okay, so we got our collider on our shape right here. Now what we need to do is just press play and test it out. But first, we need to select our crate and make sure that it doesn't fall to the ground. So we're going to set the gravity scale to be 0. We'll keep the mass at 1. Now, if we press play, you'll notice that we can move towards the crate, and if we hit it, it begins to move around. Whoops, and I just tabbed out there. Let's press play again. So yeah, we can move around here. We can hit the crate. And as you can see, whenever I hit it, it will basically move wherever we bounce. It's just like real life. When you hit something with another object, it's going to bounce off it. But we can also add some drag to this crate because right now it's just going to be floating around forever. So I'll open up linear, set the damp to be 3, and we can then press play and test it out again. So we'll hit the crate, it moves, it stops. And there we go. So let's go ahead, let's save this crate as a physics, as a scene I mean. So I'll drag to a physics folder, save that as crate. We can then duplicate this crate scene right here, Control D, and we are just going to create a load of different crates here for our player to fly around in and collide with, okay? Okay, so now we can press play, and as you can see, we can move around, and all these crates are going to interact with each other. Now, when it comes to physics inside of Godot, there is quite a lot you can do with it. There are many different game ideas. If you have a player that you want to be able to move a crate to maybe reach a higher place in a platformer, you can just make that crate a physics object and the player should be able to push it along. Yeah, and there's many other game types as well that you can use for physics. I mean, I couldn't name 100 right now, but I'm sure you can probably think of a bunch as well. So experimenting with the rigid body 2D component and also the rigid body in 3D as well, that also works as a 3D physics object. Yeah, I recommend you experiment with it, see what you can do, and try and make some creative games. So that is our physics project done. Thank you for watching. Welcome back everyone. In this lesson, we are going to be setting up our player controller. So to begin, what we're going to do is we are going to be creating a new node. So we'll click on the plus, and we are going to be looking for a character body 2D. Now, a character body 2D, this node basically allows us to just give it a velocity input, and it will automatically move our player throughout the world, okay? And we'll also take into account grounding the player, making sure they won't fall for any obstacles. So this is a great base for if you want to create a player controller. Let's rename it to be player. We need to give our player a sprite. So what I'm going to do is go into our characters folder here. I'm just going to go through here, search for a character sprite that we might want to use, something like this. We can drag that into our scene. We can then select our character sprite, make that a child of player. Let's rename it to be sprite just so we know exactly what it is, and set the position to be 0 on the X and 0 on the Y, okay? And we then need to add in a collider. So on our player node right here, I'm going to right click and go add child node, and we are going to look for a collision shape 2D. We can then go shape, create a new one, and we are going to be creating a capsule. And then just go through ahead and basically fit it to the form of your character like so. So we got our sprite, we got our collision shape. Now what we need to do is create a script that is going to basically give our player the ability to move around and jump. So for this, I'm going to go select our player. Then inside of the inspector at the bottom, we have a script property here. We're going to create a new script and call it player, and make sure that it inherits from character body 2D. If you are, make sure you do have the player node selected, and it should inherit from character body 2D right here. Click create. Now it does include some default code here, but what I'm going to do is select all of it except for the first line and delete it, okay? So we just want extends character body 2D because that gives us the ability to communicate with our character body node. We are going to be creating some variables. The first one is going to be our move speed. So I'm going to create a variable called move speed. It's going to be of type float, and it's going to be equal to, let's just say 100. So this basically means we are going to be moving at 100 pixels per second. Then we're going to have our jump force. So a variable called jump force of type float, and I'm going to make this equal to 200. Now jump force is basically the amount of upwards velocity we are going to add to our player when we want to jump. Then we're going to have another variable called gravity of type float once again, and it's going to be equal to 500. Basically, this is the amount of downwards force we are going to be applying to our player. So create a function, call it underscore physics process, and you should see the autocorrect does pop up right here, so we can just hit enter, and that's going to create it automatically for us. Now, the physics process function is generally where you want to run your physics code that you want to check every frame, and basically physics process gets run at a consistent rate per second, just because when it comes to physics and computing, it really prefers it if it is running at a consistent rate, which is what this function does. So first of all, what we are going to be doing is applying gravity. So the way we're going to be doing that is by checking to see if the player is not standing on the floor. Now to do that, we can go if not, and then is on floor. Okay, the is on floor function is built into our character body 2D, and that just returns true or false for whether or not our player is standing on the floor. So if we are not standing on the floor, then we want to modify our vertical velocity. And to do that, we can go velocity.y plus equals gravity multiplied by delta. Now, the delta is basically what converts a per frame action into a per second action, okay? And this is just how we have our gravity increase over time at a consistent rate. The next thing we want to do is have the ability to move left and right. Now, before we start detecting our key presses, we first of all want to go velocity.x equals 0, okay? We want to set our velocity to 0, and then if we are pressing the left key, we want to set our velocity to be negative move speed. Otherwise, if we are pressing the right key, then we want to set our velocity to be positive move speed. So down here on a new line, what I'm going to do is I'm just going to go if input dot is key pressed. Okay, so if is key pressed, then we want to give it a key. This is going to be key underscore left, and this correlates to our left arrow key. So if our left arrow key is currently being pressed, then we want to go velocity.x minus equals move speed. Okay, so here we are setting our x velocity to be 0, and here we are setting our x velocity to basically be negative move speed. Now, if we are pressing our right arrow key, we want to do the opposite. So if input dot is key pressed, this is then going to be key underscore right. So if our right key has been pressed, we want to go velocity.x plus equals move speed, okay? And that should make it so that our player can move left and move right. Now, let's save this script, return back into our 2D scene here, and let's test it out to see if the movement works. So I'm going to press play, we go select current, and it's going to launch, and we can't really see anything. And the reason why is because our camera isn't rendering what we want to render. So to fix this, what I'm going to do is I am going to, in our scene here, add in a new node of camera 2D. Now this camera 2D, if we zoom out, we can see this purple rectangle right here is the bounds of our camera. Now we want to zoom in a bit. So let's go to the inspector, and where we have the zoom, I'm going to change this from 1 to 3. So there we go. We've got the camera zoomed in a bit more now. We should then be able to press play. We have our environment. And with the left arrow key, I can move left, which is not actually working. And the reason why is because even though in our script here, we are modifying our velocity, we aren't actually applying it to our character body. Now, to apply it to our character body, we need to call the function move and slide, and it pretty much does exactly what it sounds. It moves our player based on the velocity, and if we are, up against a ramp, it will slide us across that as well. So we can save this, press play, and as you can see, our character falls through the ground. Now, the reason why that happens is because we have set up our tile map here, but we haven't actually given it any collision. So what we want to do is click on our tile map right here. We then want to go over to the inspector, go down to where we have our physics layers, and click add element. And this is going to basically add collision to our tile map. So now when we press play, we should see that our player still falls through. And that is because we haven't applied this tile, this physics layer to our tiles. So down at the bottom, click on tile set to open up the tile set window. We can then click on the paint button right here, select a property, physics layer 0 right here, and then we just want to go through and basically just paint in or select, holding down left mouse, all of the sprites that we want to basically have this change applied to. Okay, and you can just select every sprite here if you wish, but I'm just going to select these ones for now. We can then go back into our main scene here, click play, and we should see that our player lands on the ground and we can move left and right. And if we fall off the edge here, our player will fall off. Okay, so we have the ability to move left and right as well as have gravity affect us. But how about jumping? Well, for jumping, we're going to go to our script, and just before we call move and slide, we're going to check if input.is key pressed, and this is going to be the key underscore space for the space bar, and is on floor, okay, because we only want to jump if we are standing on the floor. Then we are going to go velocity.y equals minus jump force. Now, we're doing minus here because the way it works is if we do positive, it's just going to try and throw us down into the ground. So we can save that, press play, and now we can move left to right. And if I press space, you can see I can jump, and we can jump on these obstacles here as well. Now, we probably want the camera to follow the player as well. So for that, we can just go ahead and make the camera a child of player. And we can then move the camera up a tiny bit as well. There we go, press play, and now there we go. Welcome back, everyone. In this lesson, we are going to be creating our player controller. Okay, this is basically going to be the scene that allows us to have a player that we can move around in our 3D world. Now, to begin, we need to create our player's base node, and this is going to be of type character body 3D. So I'm going to create a brand new node in our level 1 scene of type character body 3D and click create. Now, the character body 3D node is really great as it comes with a lot of stuff built in for creating player characters. Okay, it has the ability to have physics applied, such as velocity. It can detect the ground, so it can then tell us if we're standing on the ground or not, and it can walk up slopes and detect ceilings. All some really cool stuff for having a character that you want to jump around in a physical environment. So I'm going to rename this node to be player. And then what we're going to do is we are going to drag in our player model. So we can go to our models folder, go down to where we have our character, drag them into the scene here, and then make them a child of player. I'm going to rename this node to be model, just so we can easily see what all these different nodes are called. Now, with this player here, what we can then do is we can actually resize this model a bit because we might want it to be a bit bigger. So I'm going to select our model, go to transform, scale, and I'm going to make this model 1.5 on all axes, okay? So they're a bit bigger than normal. Now, what we can do is make sure that their position is set to 0 on the X, 0 on the Y, and 0 on the Z, so that they are nice and centered on our player model, okay? And at the origin location of this player node, that should be down at the feet of the model, okay? So there we go. Now what we need is a collision shape for our player so that they can collide with stuff. So we'll create a child node of player, make a collision shape 3D, capsule shape 3D. Now in games, generally players and any other humanoid thing that you want to move around a scene will use a capsule as their collider for two reasons. First of all, it's roughly shaped like a person, and second of all, it has a smooth head and it has a smooth bottom. Now, the reason why you want that is because if you're walking around on slopes and on little edges that might clip your feet, you want the player to be able to smoothly navigate around that. Now, if you had a box, you would have sharp edges at the bottom, which could easily catch on, a set of stairs, for example. Whereas a capsule shape has a nice smooth bottom that can slide and glide along these surfaces. So what we're going to do is we're going to get into a little side view here, and we are going to adjust the shape of this collider. So I'm going to move it up here a bit, decrease that radius there, decrease the height, and in fact, let's be a bit precise actually, and I'm going to open up the capsule shape 3D right here by clicking on it. I'm going to set the radius to be we'll say 0.4. Oh no, that's way too large, 0.3. We'll set the height to be 1.2, and we'll move this collider up just a little bit so that we can just see the base of the capsule just peeking up here at their feet. And I think that should be it for our player, okay? And finally, we need one more thing, and that is going to be a camera. So the camera, we can right-click on player, add child node, camera 3D, create that here. Now this camera is going to be sort of out a bit, so whoops, we're just going to move this over here. We can then rotate it down a tiny bit so it's looking down at the player. And we can also adjust this later on if we need, but I'm just going to keep it there for now. Inside of the inspector, we want to go down and enable current so that this camera is the one that is rendering. So we can save this, we can then press play, and it's going to ask us to select the scene, which we want to set as the default scene. We'll just go select current, and we should then see, once it loads, there we go, here is our player. Now our player is pretty far away, so what we can do to fix that is we can select our camera, and we can adjust our field of view. Now I'm going to bring our field of view down to about 60, I reckon. Press play again, and we should see that we have a much better, more narrow angle on our player. Now, something else that isn't necessary for the player, but I think might be easier on your eyes, is setting up some sort of lighting, because right now our player is pretty dark. So what we're going to do is we are going to create a new node here of type directional light 3D. And this is going to basically add in the sun. We probably don't want the angle down here as if it's a sunrise, so I'm going to press E to go to the rotate tool and rotate the sun to a nice position, something like this right here, okay? So yeah, if you're making a game, try and set up the lighting so that the light is sort of hitting your character here, okay? You don't want the character to sort of be in shadow like this, as that doesn't really look too well, unless of course you're going for that sort of mood. So we then probably want some shadows as well, so I'm going to go to the inspector, open up the shadow drop down and enable shadows, just like that. Press play, and here we go. It looks much better. So now what we can do is start setting up our actual player script, which is going to control the player's movement and their jumping. Now to do this, we are going to select our player object right here. We're going to go to the inspector, go down to where we have script, and we're going to create a new script. We're going to call it player, and it's very important that this script does inherit from the character body 3D node. This should be set up automatically right here if you are creating the script on the character body 3D player node right here, but if for some reason that's not working, try it again, or you can just click on this button right here to choose the node you want to inherit from. And the reason why we need to inherit from character body 3D is of course because we are going to be accessing a lot of that functionality with movement and collision detection. So we can then click create, and that is going to open up this script right here, which as you can see has quite a bit of stuff already made for us. Now we don't really want to use any of this code, so I'm going to go ahead, select all of it and delete it, okay? Because we are going to be pretty much coding this from scratch, just so we have an understanding of what we are actually doing here. So all I want you to have is the extends character body 3D line of code here, and that is it. So in the next lesson, we are going to begin scripting our player, getting them moving and jumping. So thanks for watching, and I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to begin scripting our player controller. But before we do that, what we need to do is we need to actually set up our inputs, because this is going to allow us to easily detect which keys we are pressing, and we can pretty much define them beforehand. So to do this, we're going to go up to Project, Project Settings, and inside of Project Settings, we are going to go over to where we have Input Map. Now, Input Map allows us to create inputs, such as movement, jumping, and any other sort of buttons that you want to be able to detect. And what we're going to do is we are going to go down to Add New Action, and we are going to basically go move _ forward. Okay, click Add. That's going to create a new action down here. And what we can then do is assign a key press to that action. So we can click on the little plus next to the action here, add event, And this, we are going to press W. And as you can see, it is going to basically search through a list here. There we go, we have W, click OK, and that, as you can see here, W physical. So this basically means that whenever we are listening to the move forward action, it is going to basically trigger whenever we are pressing the W key. And this is how we're going to set up all of our movement keys. So then we can add move underscore backward, add that, click on the plus, press S to move backwards. There we go. And there we go. Okay, so what I want you to do now is go ahead and set up the left moving, the right move, as well as jump with the spacebar. So have a go at that, and I'll be right back to see how you're done. Okay, so here we go. We, of course, have move forward, move backward, move left, move right, and jump, all with an action assigned, an event, assigned to them. So we can then close out of our project settings here, go back to our player script, and begin setting that up. So first of all, we need to create our variables. Now, first variable is going to be move speed. This is going to be of type float, and let's set this to be equal to 4. This basically means we are going to be moving 4 meters per second. We then want to have another variable for our jump force, and this is going to be the amount of force we are applying upwards whenever we jump, and this is going to be equal to 8. And then we need a way of actually pulling ourselves back down to the ground with gravity. So I'm going to create a variable called gravity. This is going to be of type float, and we'll make that 20, okay? And this is going to be the force that is going to pull our player back down to the ground. Now, another one is going to be a variable called facing angle of type float. We're not going to give it a value because this is going to be set pretty much every frame. And facing angle is basically going to be the angle in terms of degrees to where our player is facing. And we need this in order to basically set our model's angle, because we're going to have our 3D model rotate to face its moving direction. And we are then going to have our model as a variable right here. So we'll go variable model. This is going to be of type mesh instance 3D. And this is going to be equal to get underscore node. And we want to get the model right here. Now, in order for this line of code to work, we need to add the @onReady keyword right here. So basically, when this node is initialized, this function right here is going to be called. So we are going to find that model node right here, and we are going to assign it to this model variable. Okay. Now what we need to do is actually start moving our player around. So how are we going to do this? Well, first of all, we're going to create a function, and we are going to create the underscore physics process function. Now, the physics process function is very similar to the normal process function, in which that it gets called every single frame, but physics process gets called at a consistent time rate per second. And this means it is good for physics, which likes consistency, okay? So inside of this function, we are going to be detecting our movement inputs. Now, to do this, I'm going to create a variable called input, and this is going to be equal to input.get_vector. Now, this input get vector is a very handy function because it can take in a number of different inputs, well, 4 inputs, and give us a movement direction. So you can see here, we need to give it a negative x, a positive x, a negative z, and a positive z. And this is going to basically convert those inputs into a direction vector, which we can then apply to our player. So what I'm going to do is I am basically going to set the first one here in brackets. And as you can see, we have a list of all of our different inputs that we just created. So the first one is going to be move underscore left. We're going to go comma. We're then going to go move underscore right, comma. We are then going to go move underscore forward, comma. And then finally move underscore backward. And there we go. So we have left, right, forward, and back, and that is going to basically create a brand new vector variable, which we can then assign to our player's move direction. And for the direction, I'm going to create a variable here called dir, short for direction, and this is going to be equal to a vector 3, and this vector 3 we can assign an X, Y, and Z value to it. So the X is, of course, going to be the X of our input, so input.x. The Y is going to be 0, since we don't want our player to be moving along the Y of the keyboard. That's going to be managed by gravity and jumping. And then for the Z, we aren't going to go input.z. The reason why is because this input vector right here is a vector 2, okay? It has an X and a Y. The X is keeping track of our left and right inputs, and the Y value is keeping track of our forwards and back movement inputs. So for this, we're going to go input.y, okay? And that should then convert this 2D vector into a 3D one, which correlates to our player moving in the real world. Then down into a new line, we can go velocity equals direction, okay? And this is basically taking this direction vector and assigning that to our character body 3D's velocity variable. Now this variable, we haven't actually defined anywhere here, but rather this variable is created and used inside of the character body 3D, which we are extending from. So that is how we can access that. And then finally, we want to call the move and slide function in order to apply that velocity. So we can save that. We can then press play and see if it works. So I can use the arrow keys, and as you can see, here I am moving around. Now, this is still very basic movement, but it does work, but there are a few issues. The first one is that we aren't moving based on our move speed, and if we walk off the edge, our character doesn't really fall, okay? They kind of just sink down a little bit here, and we can still walk around on the ground. So there are a few things that we do need to fix, but we'll go by them one at a time. Now, as a bit of a challenge between now and the next lesson, I want you to attempt to make it so that when we press play and we move around, that we move at a rate of our move speed. Because right now, we are moving basically 1 unit per second, but we have a variable here called move speed, which is set to 4. So what I want you to do is make it so that when we move around, we are moving at whatever our direction is by our move speed. Okay, have a go at that, and I'll be right back to see how you're done. Welcome back, everyone. So the first problem we need to solve with this script right here is setting it up so that our player can move at the rate of their move speed. Because right now, when we are getting direction, this is only getting a direction variable, which has a length of around 1. Okay, so we're only moving at around 1 meter per second. So how do we make it so that we move at 4 meters per second? Well, we're going to go down here to where we are assigning our velocity, and we are going to multiply the direction variable by move speed. So we're just going to go multiplied by move speed, like so. We can then save that, press play again, and see if that works. And as you can see, we are now moving around a lot faster at 4 meters per second. Now, there's also something else, and that is the fact that our model isn't rotating, okay? They're kind of just standing on the spot and just sliding around backwards, left and right. So we want to have our 3D model pretty much rotate to face whatever direction we are moving in. So to do this, what we can do is we can go down after we move and slide, and we want to check to see if our input is, first of all, greater than 0. And what we're going to do is we're going to go facing underscore angle equals vector 2. Now, what we have to do here is we base vector 2 of a capital V. We want to go input dot y, then input dot x, and then we want to go dot angle, okay? Now, the reason why we have to do this way, by putting the y in the x and the x in the y, is in order to get the y axis angle, okay? And then we go dot angle, which basically gets this vector and converts that to an angle, all right? So we're getting a direction with the input right here, and then we are converting that to an angle in terms of degrees. So now that we have our facing angle, what we can then do is we can then go model dot rotation dot y. Okay, we are modifying the y rotation because we want to rotate it so it's looking, around a pivot point. Then we want to go equals facing underscore angle. Okay, so we can save that. We can press play, and it will work, but there are going to be a few issues. And you can see if I move to the left, you can see it's all working just fine. But if I let go, we sort of snap back to facing forward. So if I move forward, you can see the character sort of snaps back to the camera, okay? and it's also pretty harsh, okay? There's no sort of smooth rotation between it. So we need to fix those two issues. Now, the first one is making it so that the character doesn't sort of flip back to face the camera whenever we stop moving. And the reason why that's happening is because we are always setting our facing angle even if we're not pressing anything. And if we aren't pressing anything, then that means that the input is going to be 0 on the Y, 0 on the X, and if we convert that direction to an angle, that is basically going to face us back to our default 0 rotation, okay? Because if we go into our 3D view here, and we select our model, go to the transform, you can see if we go to Y on the rotation is 0, it is facing the camera, okay? So if everything is 0, then we are sort of resetting to this default rotation. So we need to make it then so that we are only setting our facing angle if we are moving, okay? If we have a button pressed, that is the only time we are going to be setting our facing angle. Now to do this, we can just put this line of code here inside of an if statement, and that is going to be if our input dot length is greater than 0, then we set our facing angle. So what we're doing here is we are getting our input vector, we are getting the length of that vector, okay, or the magnitude, and this basically means if you sort of map this out on a graph, how long would that vector be? So generally, it's going to be 1 for a direction vector like so. So if that's greater than 0, then we are setting our facing angle. So now if we press play, we should see that if we can move around and stop, as you can see, our player isn't resetting back to 0, which is great. Now, finally, all we need is the ability to make our player sort of smoothly rotate between these rotations because it's pretty harsh at the moment. So to do this, we're going to go down to where we have our, where we're setting our model's rotation, and instead of setting it directly to facing angle, we're instead going to set it to be lerp underscore angle, okay? Now, lerp underscore angle, this takes in 3 values. It takes in a from, a to, and a delta, okay, or an amount. Now, from is basically what we want to rotate from, which is going to be our model.rotation.y. Our to is going to be to our facing angle. And finally, the weight is going to be sort of the amount or the speed that we want to move towards this facing angle. And for this, I'm going to set it to be 0.5 for now, although we might change that in the future. So I'm going to press play, and if I move around, you can see that what's happening is our player is sort of smoothly rotating between these different facing angles, okay? Instead of having that rigid snap, they are now lerping between those 2 angles, okay? Which is very nice. So yeah, lerp angle is very good for if you want a smooth transition between one angle and another. And you can, of course, modify the weight parameter at the back here. If you want to have it smoother, you can decrease that, or if you want it to be more harsh, you can move that up closer to 1. Okay? So that is the basis of our character movement right here. Now, all we need to do is set up the ability to jump. So, when it comes to jumping, we first of all need to make our player fall down. Okay, I think that should be the first step, because right now, if we press play, you'll see that our player just walks off the edge, and they're just kind of chilling out here. So what we need to do is we need to go to our physics process function, and right at the top, we need to go if not is underscore on floor, okay? Now this is on floor function is built into our character body 3D, and that is basically true or false for whether or not our player is standing on the ground. So if our player is not standing on the floor, then we want to pull them down. And to do that, we're going to go velocity.y minus equals, and then that's going to be gravity, okay, multiplied by delta. So we can save that, press play, and now if we walk off the edge, still not working. And the reason why is because down here where we are setting our velocity, we are setting our velocity to be equal direction multiplied by move speed. Now that seems fairly normal, but what we are also doing, as you can see, if we go to our direction variable, you can see that the y is 0. So basically, every frame we are setting our velocity to be 0 on the y, overriding the gravity right here. So what we need to do is we need to go down to where we have our velocity right here, and instead of assigning it directly like this, we are instead going to manually assign each axis. So we're going to go velocity.x equals direction.x multiplied by move speed. We then have velocity.z equals direction.z times move speed. Okay, and what we're doing here is we are basically skipping over assigning our y velocity because we don't want the y velocity to be influenced in any way by our movement direction. Okay, we only want the y to be changed by gravity and by jumping. So now we can save that, press play, and we can still move around like normal along the x and the z axis, but if we fall off the edge, our player is then affected by gravity. Okay, so in the next lesson, we are going to be finishing off our player script, or finishing off the movement side of things, by setting up the ability for them to jump. So thanks for watching, and I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to be setting up the ability to jump. Now, as you can see, I've gone ahead and actually added in a bunch of little comments right here. Now, a comment, we can just add in a hashtag or shift3, a pound sign, and that is going to turn this line of code gray. And this allows us to basically type in whatever we want, and it's basically a way of us adding in little notes to our code, okay? So once we start getting a lot of code like we have right here, it's good practice to add in comments so that when you come back to it later on, you can easily see what each thing done. And as you can see, I've added a line of code, I've added a comment to pretty much each line of code explaining what each individual thing we are doing here and how that's working. So feel free to add your own comments to your own code, as it can be a good way to sort of reinforce what you're doing by commenting down exactly what it is that you're doing. And maybe even before creating a function, you can add in multiple lines of comments, pretty much going step by step of what you're trying to accomplish. So let's get ourselves jumping. So after we apply gravity right here, we are going to go to a new line and we are going to create an if statement. Now this if statement is going to check two things. First of all, it's going to check to see if we are pressing the jump button, which is our spacebar, and it's also going to check to see if we are on the floor, okay? Because if we are up in the air, we don't want to be able to jump. So we'll go if input.is action pressed, okay? And that's going to be the jump action right here. And we can also combine two conditions together because this is action press returns true or false. We can then go and, okay, and that should turn red, is underscore on floor, okay? So this if statement is only going to run if these two conditions are true. So if we are pressing the jump button and if we are on the floor, then what we want to do is we want to basically set our y velocity. So we're going to go velocity.y equals jump force, okay? So we're setting our y velocity, so this is going to instantly shoot us up into the air. So we can save that, press play, and now we can move around like normal. We can then jump, and as you can see, it pretty much leaps us up into the air, and as we're in the air, our gravity is taking over and pulling us down, okay? Because once we jump into the air, we are no longer on the floor, so this gravity is then going to be applied, dragging us back down to the ground, allowing us to then jump again once we touch the ground. Now, one more thing I reckon we can do, and that is setting up the ability to basically reset our player whenever they fall off the edge. Because right now, you know, we can have our player, we can jump around, but what if we accidentally miss the platform and fall down? Well, we're pretty much going to be falling forever at this rate, so instead what we need to do is have a function which can reset our player and reset the scene. So in our player script, we're going to go down here, we're going to create a brand new function, and this is going to be called game over. And this function is going to be called when a number of things happen. First of all, whenever our player falls off the level, this function is going to be called. Whenever we hit an enemy or a spike or anything that we want to basically trigger a game over state, that is when this function is going to be called. And what we're going to be doing in this function is we are first of all going to get the tree. So this is going to get the node tree of our current scene. And we then want to go dot reload current scene. So this is going to get our tree and it's going to basically reload whatever scene we are in. Okay, so if we are in level 1, it's going to reload level 1. If we are in level 10, it's going to reload level 10. So we can save that. We then need to check to see if our Y position is below a certain value. So inside of physics process, this can also be done in the normal process function if you wish, but I'm just going to do it in physics process just because we have everything already here. We are going to go to a new line here right at the bottom, and we are going to check to see if our global underscore position dot y is less than, and let's just say -5. Okay, so if our y is less than -5, then we are going to call game over. Okay, so if we fall off our level and our y position drops below -5, we are going to reload our current scene. So let's go back to 3D. And if you're not too sure on what you should set that value to, you can just select your player, open up their transform here in the inspector, and keep an eye on that Y position. So when our player falls below this right here, that is when we're going to reload our scene. You could make it a bit closer if you wish, but I'm just going to keep it to 5 for now. Let's press play, let's jump off the edge and see what happens. And there we go. Once we reach -5, our player is instantly snapped back to the top, and that is because we are reloading the scene. So all the collectibles and everything else you might have in your level will also reset at this point as well. So there we go. Welcome everyone. In this lesson, we are going to be making a start on our day-night cycle. Now, the day-night cycle is basically going to work as it does in real life. We're going to have a sunrise, a sunset, and the lighting and the sky is going to be changing color and intensity based on the current time. So to begin, we need to add in a directional light to act as our sun. So I'm going to create a new node here of type directional light 3D. We can move it up a bit just so we can see in the direction it's pointing. And I'm going to rename it to be sun. Now, if we go to our rotate tool by pressing E, we can rotate it, and as you can see, it changes the intensity based on the rotation, okay? If we have the sun pointing directly down, you can see the light is being shone directly down onto our surface, whereas if I put it more horizontally, the sun is coming at a much sharper angle, and if I point it up, it's basically dark. So that's the basis of how we are going to do our day-night cycle. We are going to be rotating the sun over time, and that is going to change the angle of our shadows as well as the intensity of the light. So what I'm going to do is in the inspector, I'm going to go over to where we have the shadow drop down and enable shadows just so we can see that actually a bit easier here. As you can see like that. Maybe rotate on a bit more of an angle just so it's a bit off center. There we go. Now, what we need to do is we also need to create a moon, because just like the sun, the moon also emits a light, even though it's a lot dim, but we are going to add a moon, and it is also going to have shadows, but they are going to be a bit faint. So I'm going to right click on sun, I'm going to go down to where we have the duplicate button, I'm going to rename it to be moon, and one more thing we need to do with this moon is over in the inspector, we need to go to where it says sky mode and change this from light and sky to just light only. Now, the reason why is because if we look up into our sky here, you'll see that we have this little white dot with a bit of a haze around it. Now, the way we're also going to be doing our day-night cycle is by affecting the skybox. And the skybox we'll be creating is going to have a little sun visual like this. And if I select our sun object, our sun directional light, and rotate it, you can see that this skybox is changing based on the rotation of this directional light. Now, the reason why I had to disable that on the moon and set it to light only is because we don't want the moon directional light affecting the position of this sun, okay? So that's why we have to set it to light only. Now, we also want to go ahead and toggle the visibility to be false for the moon. So over in the scene dock here, I'm going to click on the little eye next to moon to just disable that for now because we don't want the moon and the sun out at the same time. And then what we need to do is actually create the sky, because right now, if we go ahead and play our game, you'll notice that, the sky is missing, okay? It's just a gray emptiness. And the reason why is because this is just a placeholder for the Godot editor here, just to see what it looks like. So what we need to do is actually go ahead and create this. Now, to do that, we are going to create a brand new node of type world environment. Now, the world environment node is very handy as it has a lot of different settings that we can change to affect our environment, okay? Things like our skybox, fog, glow, ambient occlusion. So over in the inspector, I'm going to go to the environment property here, and I'm going to click new environment. That's going to create a step 1. We can then open that up, and you can see all the different things we can change here. Now for us, we want to go over to where we have the background, and we want to change that from clear color to sky. Now, as you can see, a little sky drop down has appeared. We'll select that. We'll click on sky property and go new sky. We can then open that one up and go even further, and where it says sky material, we need to go ahead and create a new sky material, which is going to be applied to our sky. Now you can see there are a number of different ones here, and the one we're going to be creating is a procedural sky material. So we'll create that, and it should pretty much just look as it done before. But now, if we press play, you'll notice that it appears in our game as well. Okay, so we're one step closer to our day-night cycle. Now, what we also need to then look at is the different properties that we are going to be modifying on this sky material. Because as well as adjusting our sun's angle, we are also going to be changing things such as the light intensity, the light color, because the lower the sundown is, the less harsh it needs to be, and the lower the sundown is, the more sort of orange we want it to appear as well. But as well as the light, we also need to modify our sky material. Now, the aspects of our sky material that we're going to modify, if we open up that material here in the inspector and go to the sky drop down, you'll see we have top color and horizon color. Now, these two colors are basically what we can see here. The horizon is a gray, and it transitions into this more blue top color. Now, we can change these by just modifying them like so, make the horizon color a bit of a lighter blue, because the horizon is generally a bit lighter. And as you can see, it looks much more like a sky right now. But you may notice that the ground here below the horizon is still grey. And that's because the ground has a different color from the top sky. So if we open up the ground drop down, we can change our bottom color to be similar to our sky. And in fact, I'm just going to copy and paste the top color to be the bottom color, and the horizon color to be the ground horizon color. Okay, there we go. So now we can press play, and we have a nice looking sky with a sun in the sky. Okay. Now what we need to do is actually have the directional light move over time. So how can we set that up? Well, what we're going to do is we're first of all going to put our sun, our moon, and world environment inside as a child of an empty node. And that's just to make things a lot more neater, so we can have our day-night cycle sort of bundled in a single node that you might want to save as a scene and then drag into other levels or other games that you're creating. So I'm going to create a new node of type node 3D. I'm going to rename this to be day-night cycle. And then I'm going to drag in our world environment, our sun, and our moon. Okay, so we have those three nodes as a child of our day-night cycle. Now, on the empty day-night cycle node, we're going to go ahead and create a new script. This script is going to be, of course, called day-night cycle. Click create, and we can begin scripting. Now, at its core, we are going to have a variable called time. So I'm going to go ahead and create that here, variable called time of type float. Now, time is basically going to be a number ranging from 0 to 1. And if I hop over into 3D, I'll explain what that means. Basically, this time variable is going to move from 0 to 1 over time, okay? And we can adjust how fast that is. And basically, that time variable is going to affect everything from the rotation of our sun and our moon to the color of the sky, to the color of the light, pretty much everything. So if it is 0, then that means we are at midnight. So our sun is going to be pointing directly up. And as that number ticks up at around 0.5, that's going to be midday. And then back to 1, that's going to be midnight. So it's basically going to be a full rotation, you could say, from 0 to 1. And then once we reach 1, we're going to then jump back to 0 and go up again. So inside of our script, we have our time variable. We also need a couple other variables. One of them is going to be our day length. This is going to be type float, and this is basically going to be how long our day is going to be in terms of seconds. Now, for now, I'm just going to set this to be, we'll just set it to be 10, just so it's going to be a pretty quick day. Actually, no, I'll make it 20. Okay, 10 seconds for the day, 10 seconds for night. We then want another variable for our start time. Okay, and this is going to be a number from 0 to 1. So if I set this to be 0.3, that is going to be around early morning. Okay, you can think 0.3, this is going to be around, 5 a.m. Then we're going to have another variable called time rate, and this is a variable that is just going to basically convert our day length into a rate that it can add to time. Now, in order to change these two variables, we're going to add an export tag at the start, just so we can modify those in the inspector here. You can see if I select the day-night cycle, we can change our day length and start time. Okay, now as well as these variables, we also need our sun, because we want to affect the sun's rotation, so we need the sun. So down here, I'm going to create a variable called sun, and it is going to be of type directional light 3D. Now, in the next lesson, we are going to put these variables to use and actually start rotating the sun around and then affecting our sky color, our sun color, and then our moon as well. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. So let's get our sun rotating. So here inside of the ready function, this is where we are going to set up a lot of the initialization things that we need to do. So first of all, we are going to set our time rate. Now our time rate is going to be equal to 1 divided by the day length, okay? And the time rate is basically how much we are going to increase time per second. So if our day length is long, time rate is going to be smaller, whereas if the day length is very short, time rate is going to be longer, okay? We then want to set our time. So time is going to be equal to the start time, because we might want to start in midday, we might want to start at midnight, and we need to set that at the start of the game here. Then we also need to get our sun, and our sun is going to be equal to get_node, and we just want to go and get that sun right there. Okay, so we got the things that we all need set up here. Down inside of the process function, this is where we are going to run all of our code. So the first thing we're going to do is start to increase time over time. So we're going to go time plus equals time rate multiplied by delta. Now we're multiplying it by delta because we want to increase it by time rate every second rather than every frame. Now this is good, but what happens when time reaches 1? Well, it's going to keep on ticking up, and we want time to basically loop from 1, then go back to 0, and once it reaches 1, it goes back to 0. So we sort of have this 0 to 1 range that repeats over time. So we're going to make sure that if time is greater than or equals to 1, then we're going to set time to be equal to 0, okay? Like so. Now we need to actually rotate our sun. We need to get this time variable and make that affect the rotation of our sun. So how do we do that? So we're going to go sun dot rotation underscore degrees dot x, because we're going to rotate our sun along its x-axis, and we're going to set this to be equal to time multiplied by 360. Now the reason why we're doing this is because if you remember, degrees, a full circle is from 0 to 360 degrees, and our time is a range between 0 and 1. So if our time is at, let's just say 0.5, that means our rotation on our x-axis is going to be 180 degrees. If time is, let's just say 0.25, then the rotation is going to be around 90 degrees, okay? So we can save this and see what it looks like. Press play, and if we look around, we can't really see it. Okay, but there's our sun rising up into the sky, and it's going to then set down at the horizon, okay? And that's great. You can see it's working pretty much in the way that we want it. But there is one issue, and that is the fact that it's pretty much inverted. Because right now, if we go up here and we set our start time to be 0.5, okay, in the inspector here, that must mean that our sun is going to be starting directly above us in the sky. So if I press play and look up, we should see the sun. But I don't, okay? You can see the sun sort of starts on the horizon, but it should be starting up there in the sky at midday. And the reason why is because we need to add a bit of an offset to our rotation. So I'm going to go down here, And after we multiply it by 360, we are just going to add 90 degrees to that, okay? Save it, press play, look up, there we go. The sun starts directly above, and then it sets, and it then goes around and back up again. Okay, so there we go. Our sun is now where it should be in the sky, okay? 0.5, and if I set this to be 1 and then press play, our sun should be down basically below the surface, so we can't see it in the sky. So now what we need to do is adjust the intensity and color of our sun over time, because right now we have the sun go up and goes down, but you know, it's not really dynamic. So what I'm going to do is I'm going to go back up here to where we have our variables, and I'm going to create a new variable here called sun_color, and this is going to be of type gradient. We then also want to have another variable called sun_intensity of type curve, and these we then want to also export so that we can modify them in the inspector. And let's have a look at what these are. So if we go over to the inspector here, you can see we have sun color, and if I click it, we can create a new gradient. And if I select that gradient, it's going to open up here. Now, the way a gradient works is we have different points that we have colors. So here we have black here at the left and white on the right. And you can see how it sort of transitions from one color to another. And what we can then do is sample this gradient at a certain position in time. Because pretty much on the left-hand side, this has a time of 0, and on the right-hand side is a time of 1. So if we use our time variable over here to sample a color from our sun color gradient, we can basically change the color of our sun over time. So what we need to do is with this sun color gradient, we want it to pretty much be white in the middle, and as it starts going off to the edges, that is basically going to be midnight. So right now, the black one here, this is pretty much midnight, and this one here is midnight as well. So what I'm going to do is I'm going to create a color directly in the middle here. I'm going to click on the little color box, and then we can modify it to be a sun color. So I'm going to make it something like this. There we go. I reckon that would be a good color for our sun. And then on the edges, I'm going to make this go down into a more of a deep orange, okay? Because at the sunset, we probably want a nice orange color. So we can change that here. There we go, something like that. And then we also then want to just copy the hex of that and paste it on the left-hand one. There we go. Okay, so you can see, now the reason why we're not making our sun black at this point in time is because the sun is also going to lose its intensity as well. So we are just looking at the color of the sun. So at midnight, it's going to be sort of orange, and then it's going to slowly reach to white, and then back down to orange. Now, if you want to be very precise in how these nodes are positioned, we can open up the raw data here and open up offsets, and then we can change the values. So for 1, I'm going to set that to be 0.5, so it's directly in the middle here. Okay. Now what we can do is back inside of our script, we can go down, and where we set our sun rotation, we are then also going to go to a new line, and we want to basically set the sun color based on this gradient. Now to do that, we can go sun.light_color equals sun color, so we're accessing the gradient, dot sample, okay? And then we just need to give it the time variable like so, okay? So we can save that, press play, and now you may notice when our sun rises up into the sky, wherever it is, because it's starting at the bottom, there we go, it rises up, and it slowly changes color. And you can kind of see it actually has the color as well, so we can see how it turns into a more stark orange as it goes down, and there we go. Now let's actually start our sun at, let's just say 0.3. 0.3, so it starts off a bit more in the morning there, okay, rises up. Now we probably don't want this orange to be around midday, so what I'm going to do is I'm actually going to drag this center node around to the 0.3 mark. Then I'm going to create another one, add that around 0.7, and I'm just going to make that color be the same as this one here, okay? Just so it's white for a lot longer than it is orange, okay? Because we don't want it to really be orange at around 10 o'clock in the morning. That might look a bit weird, so have something a bit more like this. Okay, so in the next lesson, we are going to be working on our sun intensity as well as setting up our moon and our sky colors. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. Now, before we continue on with our day-night cycle, I want to go ahead and just add in some trees to our environment, just so we can have a bit more things to look at. So I'm going to go ahead and create a new node of type static body 3D. I'm going to call it tree. Then I'm going to drag in our tree pine model as a child of that tree. And we are then going to rename that to be model, set its position to be 0, and set the scale to be around 4, just so it's bigger than our player. We can then attach a collider to this, so a collision shape 3D. I'm just going to make it of type cylinder shape, and then we can just increase it in size, like so. Okay, we can get our tree, move it up here, move it around, and there we go. Now I'm also going to go ahead and save this as a scene, just so we can duplicate it around. So I'm going to drag that into the file system, save that as tree, and there we go. So now I am just going to go ahead and begin just copy and pasting a couple of these trees around here. Okay, just so we do have something to look at when testing out our shadows and all of that. So we can press play, and there we go. We have our trees, they're casting shadows as the sun rises and sets. Okay, now what we want to do is set it up so that the sun's brightness gets affected over time as well, because right now it's just the color. So what I'm going to do is I'm going to select our day-night cycle, go over to where with the sun intensity, and create a new curve. Now, a curve works very similar to a gradient in the sense that we can sample a specific value from a certain point in time. Now, as you can see here with our curve, the x-axis represents the time, so 0 is going to be midnight, 0.25 is going to be morning, 0.5 is going to be midday, and 1 is going to be back at midnight. And the vertical axis is going to be the intensity of our light. So 0 is basically going to be the lights off, and 1's going to be full brightness. So what we're going to do here is we're going to right click and add in a point. So I'm just going to move this around the middle here. We can then right click again and add in another point. And I'm going to bring this around 0.2 here. We can then add another point, bring this around 0.8, and there we go. So we have our curve here. But we probably don't want a little bit of high intensity in midday. We probably want the intensity to be more normal across midday. So I'm going to drag this top point over to around, let's just say around here, 0.3, add another point, drag this up to around 0.7 here, okay? And there we go. Now we can of course go ahead and adjust these as we see fit. Something like that, I reckon, there we go. Okay, and if you do want to have more fine control, you can open up the points drop down and modify their positions directly here. So we can save that. We then want to go over to our script, and here what we're going to do is go to a new line and go sun.light_energy equals sun_intensity.sample at time, okay? So when we're at midday, we're going to have full intensity, and when we're at midnight, we're going to have basically none. So save it, press play, and let's have a look. So the sun rises up, it gets to full brightness about there, and as it begins to set, it goes down, 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 and it should be at around 0 now. And you can see on the tree, there is literally 0 light being applied to it. But we still have brightness to it. We can still see the colors, we can still see the sky, and that's because we haven't actually added in our moonlight, and we haven't added in the environment changing the sky color over time as well. So let's get started on that. Now, as a bit of a challenge, I want you to go ahead and set up the moon. And basically what I mean is I want you to go ahead, create a new variable called moon, create a moon color gradient, create a moon intensity curve, and then just like with the sun, I want you to go ahead and set it up so that it rotates over time, but make sure that it is opposite to the sun. So when the sun is directly above, the moon needs to be directly below. Okay, have a go at that, and I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. Pretty much what we want to do is inside of our day-night cycle script here, I'm going to first of all just add a little comment here separating these variables. So we'll just go sun, go down here, create moon, and then for the moon, we're going to create a variable called moon of type directional light 3D. We then also want to have a variable called moon color which is a gradient. And we then want to have another variable called moon intensity, which is going to be a curve. Okay. Down here in the ready function, we want to get the moon. So we'll go moon equals get node moon. There we go. And then down here in process, we are going to go to a new line. We're going to add a little comment here for moon, just so we can sort of separate these, so it doesn't look like all just one big mess. And now to rotate the moon, it's going to be a bit different from the sun. We're going to go moon.rotation underscore degrees.x equals time multiplied by 360 plus 270, okay? So this basically means that the moon's rotation is going to be the polar opposite of our sun. So when the moon is rising, the sun is going to be setting. Okay. And then just like with our sun light color, we can actually just copy and paste these two lines of code and just replace sun with moon, okay? And there we go. Now, over in the inspector, we should see that we have two new properties, moon color and moon intensity. Now, when it comes to moon color, it's not really going to be changing that much over time, so I'm just going to set this to be a new gradient, but I'm just going to make the moon color just be a single color. So I'm going to just add in a new color here, and I'm just going to make this be a dark blue, okay? Something like this. There we go, just the dark blue. We can even delete that other node, so it's just one flat color, okay? So it's just going to be that dark purple color. Now for moon intensity, this is basically going to be the polar opposite of our sun intensity. So we're going to add a new curve here. Now we want our moon to be most intense at midnight. So I'm going to add a point, drag it up there, add another point, drag it up there, add another point in the middle, and bring that down. But we don't want the moon to really be that intense during like 10 in the morning. So I'm going to drag this around to 0.25, add another point, bring this around to 0.75, okay? And there we go. So now what we can do is press play and see how it works. But before we do that, we need to enable our moon in the scene here so that it is visible. Okay, press play. And it's going to look a bit weird because we do have two lights active at once, but as you can see, our sun's going to be setting here, and then our moon is going to be rising. And as our moon rises, we should see that we have another shadow appearing right here, which is nice. And as that sets, our sun comes up again, and its shadow appears as well. Okay, so that's all working fine. One more thing that we are going to do is we are going to set it up so that when the sun is in the sky, the moon is going to be disabled, and when the moon's in the sky, the sun is going to be disabled. And the reason why is it's just going to make it easier, you know, for calculations and lights. So what we're going to do is we're going to go sun.visible equals, and we are just going to add in a little condition here, which is just going to be sun.light_energy is greater than 0. So if our sun's light energy is greater than 0, then that's going to be true. Otherwise, it's going to be false. And we can do the same thing for the moon. So moon.visible equals moon.light energy is greater than 0. Okay. So basically, we're going to disable a light when its energy is 0, just saving on potential performance there. Okay, and we're just going to call this enable/disable moon and sun. Okay, and if we press play, nothing's really going to change. It's going to be the exact same. So now what we need to do is start making it so that our sky changes color based on the time of day. Because right now, even at midnight, our sun is still blue. So what I'm going to do is I am, first of all, inside of our script here, we're going to create a couple new variables. First of all, we're going to go down here, create a comment, call this environment. We first of all need our world environment node in order to change its properties. So I'm going to create a variable, call this environment of type world environment. Okay. And then what we're going to do is we are going to create a variable. This is going to be an export because we're going to change it, called sky top color. Okay. This is going to be of type gradient. We're then going to have another export called sky horizon color of type gradient. Now, we're not going to have a ground horizon and a ground bottom color just because we're just going to use these ones again, okay? So down inside the ready function, we can go environment equals get node world environment. And then what we want to do is we want to go down here, and we're going to add a little comment. This one is just going to be setting the sky color. And to do this, we need to access a material property. And to do that, it's going to be a pretty long line of code. We're going to go environment.environment, so accessing that environment property, then .sky underscore material .set, and then we need to basically give it a property. So this property is going to be sky underscore top underscore color. We then go comma, and we need to give it the value. And this is going to be our sky underscore top color dot sample time. Okay, so this is a pretty long line of code with all this stuff that we're doing here. But we can then go ahead and just copy and paste this line of code. And the next one is going to be the property sky horizon color. Horizon color like so. And this is going to be sampling from the sky horizon color property that we have as well, okay? So that's the top of the sky. Now for the ground, we can copy and paste this once more. And this is going to be sky underscore, oh no, it's going to be ground underscore bottom color and bottom underscore horizon color. Oh, ground horizon color, okay? There we go. So that's what we need to do in order to get this sky changing over time as our time variable changes. So we can save that, go into our scene here. Now, what we're going to do is we are going to go to our sky top color. We are going to create a new gradient for that. And the top gradient, we are going to open it up here. So for midday, we want it to be nice and blue. So for that, I'm going to add in a node here and a node here, just roughly for now. I'm going to set this color to be a blue, light blue like so. The other one here can also be a light blue like that. Okay, we might actually make it a bit darker just because the sky top color. Okay. And then for the edges, this is going to be a sort of darkish, a bit of a darkish purple. Okay, so something like, or a bit of a darker blue, I mean. So something like that, okay? So as it gets more towards nighttime, it's going to get a bit darker, the sky. We might actually make that a bit darker here. Okay, so that's going to be the nighttime color. We can then actually just copy this hex code, paste it on this one right here. Now I'm going to open up raw data offsets because I do want to be a bit precise with this. So with this one here, I'm going to set that to be around 0.1. I'm going to set the last one to be 0.9, just so we have more dark color at the end here. I'm going to set 2 to be 0.4 and 2 here to be 0.6. Okay, so you can see this is the gradient we're going for. So then we can create our sky horizon color. So we can go through pretty much the exact same process as we done with the top one. But as well as this, I also want to add in a bit of a orange glow on the horizon. So I'm going to add another node here. I'm going to bring this down to a nice orange glow, something like that. Then copy that, paste that over here. So that we have this little orange glow at the sunrise and sunset. So we can save that, press play, and see what it looks like. So as the sun rises up, you can see the sky gets very bright. And as the sun sets, we should see that it goes into more of an orange haze and back down again. So there we go. And that is the basis of our day-night cycle pretty much working. Hey everyone and welcome. In this lesson, we are going to take the first step in setting up our NPC AI project, and that isn't actually going to be in Godot, but rather over here on the OpenAI website, because in order for us to actually interact and communicate with the OpenAI servers, we first of all need to set up an API key, and this is basically going to be what allows us to send our messages and get an AI response back, okay? So to do this, we're going to go to the openai.com website, and what you want to do is just click on sign up, and then you can go through the process of signing up your account. Okay, you can log in with Google and a number of other different services, so that should be a pretty quick process. Okay, now once you have finished logging in and signing up, you should be on this screen right here. Now there's three options. We can go to ChatGPT, DALL-E, or the API. Now these two, the first two, these are pretty much interacting with the API in our web browser, but we don't want that. We want to be able to interact with ChatGPT inside of our Godot project, so we are going to click on API right here, and this is going to take us over to the OpenAI platform. Now, we need to get ourselves an API key. So to do this, we're going to go to the top right corner where we have our name, and we're going to go down to View API Keys. Now, here what we can do is go down to where we have Create New Secret Key, and we can then give it a name. So we might go for this one, Godot AI NPC. Okay, click Create Secret Key. That's going to create it right here, and then you want to basically copy this and then keep it somewhere safe, okay? Paste it, keep it, because this is a very important string that we are going to be needing later on. We can then click on Done, and that is it. Now, it is important to know that if you are signing up with a free account, then you do have a limited credit, a limited amount of credits available too, because each time you communicate with the API, it is going to cost money. Now, they do give you some when you sign up for free, but those will eventually run out. So I do recommend, if you are looking to create many projects, and even especially if you're looking to do then image related AI generations later on, then you should look at setting up some billing information, okay? So do be aware of that. You can, of course, go over to where you have usage on the left-hand side here to see how much you're using. And yeah, so just keep that in mind when you are working with this course, as if all of a sudden it stops working and you're no longer able to communicate with the API, that may be the reason, okay? So we have our secret key. Now in the next lesson, we can jump into Godot and begin communicating with the API. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to begin setting up our Godot project. So here I am in our project manager, and we are going to go ahead and create ourselves a brand new project. So I am going to go ahead and just call this one, let's just say our Godot NPC AI. Okay, we can then choose a project path, click on the create new folder to create a new folder in that path, and then we can click create and edit to start up the editor and begin creating our project. Okay, so here we are inside of Godot. Now the first thing we're going to do is create our root scene here, and this is going to be of type 2D because we are making a sort of top-down pixel art 2D game where we can walk around and talk with NPCs. Although if you do want to make this 3D, you can of course do that. The overall dialogue system is pretty interchangeable with 2D and 3D and any other sort of type of game you want to create. So I'm just going to click on 2D scene here. Going to rename the node 2D to be main because that's what I generally like to do with these. We can then save this, and we're just going to save it as main.tscn. Okay, so our scene is saved. We can click on the play button at the top right corner, click select current, so it loads into this scene every time we click play, and we can then of course see our game right here. So we've got that all set up. Now what we can do is start making some requests, okay, because we want to start talking to our AI. Now to do this, we are going to go ahead and create ourselves a brand new script. But we first of all need a node to attach that to. So I'm going to go over to our scene view here. I'm going to click on the plus, and we are going to create a new node. Now this node isn't really going to have a presence in the world, so it can just be a base node right here. Create that. I'm going to rename it to be Game Manager. Okay. And then what we can do is then we can go over to the inspector here, go over to our script property, click on the little arrow, and we're going to create a brand new script for our game manager called, as you guess, Game Manager. So we'll create that here, and here we go. So now inside of our code, what are we going to do? Well, first of all, we're going to delete the process function since that is not going to be needed for this course, okay? We only really need the ready function that is already laid out in the base script here. And then what we're going to do is we're going to create a number of variables. Now we are going to have quite a few variables because we do need these to keep track of the different parameters we might want to tweak. So first of all, we're going to have a variable for our API key. So I'm just going to go API underscore key. This is going to be of type string. So we're going to define the type as string, and this is going to be equal to, of course, a string. Now, this is going to be the API key that we just created before, so I'm going to paste that in right here. There we go. Then what we're going to need is we are going to need a URL. Now, the URL is the actual website URL link that we are going to be sending our API request to. Because in Godot, we are going to use something known as a HTTP request. That's basically where we can send something to a server, to a website, and then wait until we get a response back, okay? So in order to do that, we need a URL to send our things to. So we're going to var URL of type string. This is going to be equal to https://API dot openai.com/v1/chat/completions. Okay, and do make sure this is exact because this stuff is needing to be basically exactly the same as this for it to work. Then what we're going to do is we're going to have a variable for our temperature. This is going to be of type float, and we're going to have this at around 0.5. Now, temperature basically just defines how consistent or sporadic you want your AI generations to be. So for our dialogue, if you're noticing that, you know, it's either a bit cookie cutter or it's a bit too crazy, you can adjust this value back and forth from 0 to 1 in order to fine tune it. But we're just going to keep it at 0.5 for now, that's about the middle ground. We then need a variable for our max tokens, which is going to be an int, and this is going to be 1024, okay? And a token is basically like a character or a word, okay? And this is basically the maximum amount that we can use with the AI, but we're probably not going to be exceeding this. So then what we're going to do is we need to create a variable for our headers. Now, when you are making requests to an API, generally you want to send over some information that is more metadata, more information that's in the background that it just needs to know, okay? And we need two things. So we're going to go equals, we're going to create a new array here, and we're going to have two things in our array. First of all, we're going to have a string, and this one is going to be content-type application/JSON. Now this basically means that the format that we're going to be sending and the format that we're going to be getting in return is going to be of type JSON, which is basically a way that data can be serialized and sent over for us to use. We're then going to go comma, and the second one is going to be authorization::bearer. Now, you do need to make sure that these also are case sensitive and are written exactly as I have right here. So bearer, we're then going to go space, and then we're going to go plus API_key. Okay, so this is pretty much where we are sending our API key to the API so that it knows who we are and it knows that we actually have a valid key and we should be able to use the API. Next up, we need a variable for the model. Now, with OpenAI, they have a number of different models to use that are used for different purposes. For us, our model is going to be GPT-3.5-Turbo, okay? And this is basically just your run-of-the-mill chat completion API, okay? So if you've ever used ChatGPT before on a website, this is basically it. You send a message, it sends you a response, and you can go back and forth, okay? Then what we need is we then need a variable for the messages, which is going to be equal to an empty array. And a message is pretty much going to be either something that we send to the AI or something that the AI sends back. Now, the reason why we need to keep track of all of our messages is because when it comes to ChatGPT and the OpenAI models, whenever we make a request, we need to send all of our chat history over to it, okay? Because otherwise it won't remember unless we ourselves are keeping track of it and send it all over, okay? So that is why generally the more and more messages you send to the AI, the sort of slower it gets. That is because each time you're sending a message, you're sending the entire chat history over, and that of course keeps growing the more messages you send. So we've got that. Now, what we need to do is we also need to go ahead and create another variable for our request. And this is going to be of type HTTP request. This is a node inside of Godot. And this is basically the node that is going to manage all of the sending information to the API and receiving it, and then telling us when we have received it so we can then do something with that. Okay, and down here inside of the ready function, which gets called right at the start of the game, we are going to create that request. So to do this, we're going to go request equals HTTP request.new. So we're creating a brand new HTTP request node. We then need to add that as a child to our scene here. Okay, so that it is so it basically has a place inside of our scene tree. Then what we need to do is we need to connect this HTTP request so that when it has received information, we have a function call, okay? Because right now, it's not really doing anything. So we're going to go down here and create a new function called onRequestCompleted. And this is going to have 4 parameters: result, response code, headers, and body, okay? And we're just going to chuck in a pass right here just so it's empty for now. And then up here inside the ready function, what we're going to do is we are going to go request.connect. So we are connecting a signal to a function, okay? Very similar to if you go into the node panel here and connect these signals. It's basically the same thing, but we're doing it inside of a script. So the signal that we want to connect is going to be request_completed. So when we have received something from the API, this signal is going to be called, and we want to connect it to the on_request_completed function, okay? So there we go. So whenever we send something with our API and we get a response, this function down here is going to be called, and then we can read, okay, what do we get in response? So in the next lesson, we're going to be continuing on with this, and we're going to actually begin sending and receiving information. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to continue on with our script right here, and we're going to set it up so that we can finally send a request to the OpenAI servers and get a response back. So in the previous lesson, we set up all of our variables. We basically created our HTTP request node and set it up so that once we receive information from whatever request we are making, this function down here gets called. So now what we're going to do is we are going to create a function that we want to call whenever we want to basically send some dialogue over. Okay, so whenever we want to talk to the API, this is the function that we're going to call, and we are going to call it function dialogue_request. And sending over a player dialogue parameter here. Now, inside of this function, we need to do a number of things. Okay, first of all, what we're going to do is we need to create ourselves a new message and add it to our messages array. Okay, because remember, whenever we are sending over, whenever we want to talk to the AI, we need to send over all of our previous messages as well. And to do that, we're going to first of all begin by adding a new message to that list, which is the current one. So for this, we're going to go messages.append. So we're adding in a new element to the array here. We're going to create 2 squiggly brackets like this, and we're going to have 2 values inside of this object. The first one is if we create a string, we're going to say role, and this colon is going to be equal to user. Now let's actually make it so it's a bit easier to see this. Okay, something like that. There we go, user. And then we're going to have content, which is going to be our player dialogue. Okay, so what we're doing here is we are basically adding a new object to our messages array here, and that object contains 2 values. It contains a value called role, which is equal to user, and a value of content, which is equal to whatever we are sending over here as a parameter. Now, role, this is basically user, so this is us saying something, and when we get a response from the server, it will also send back a message, and that message will have a role of system, and the content will be whatever the AI is saying back to us. Okay, so we're basically creating our little text box that we are sending over in a way. Then what we need to do is we need to create the body of our request. This is basically what's going to contain our messages, the temperature, the max tokens, the API model that we want to use. We're basically compiling a lot of our variables here into a body that we are then going to send over through the request. So here I'm going to create a variable called body, and this is going to be equal to json.new.stringify. Okay, add a squiggly bracket here and open that up. Now, what we're doing with this line here is we are basically making it so that all of the objects and the values that we add inside of this body, they are going to get turned into a JSON format. Because when we are talking to the AI, we need to send over our values and our requests in a JSON format. And this is basically what's going to do that automatically for us. So in here, we can go something such as messages, okay, colon, sending over the messages, comma. We can then go to a new line here. The next thing we need to send is our temperature. So temperature. Make sure all of this is also spelled correctly because it is going to be needed in order for the AI to understand what we actually want from it. So temperature. We can then send over our max tokens. And finally, we want to send over the model that we want it to use. So model, like so. And there we go. So we are creating our message, we are adding it to the messages array, we are then creating the body of our request, which is basically compiling our messages, temperature, max tokens, and model. Now what we need to do is actually send this request off. And to do that, we're going to create another variable here, and we're going to call this one we'll call it send request equals. We're going to access that request HTTP request node that we created up in the ready function dot request. And for this function, we need to give it a few things. First of all, the URL. So we'll send over the URL variable. We need to give it the headers. So we already have that headers variable, so we'll send that over. We then need to send over the method. So what type of request is this? And as you can see, there are a large number of different types of requests we can make. Some of these might be getting, some of these might be deleting things, but for us, we want to be posting. And posting basically means we are sending something over, okay? So method underscore post. Then what we want to do is send over the body. And that is pretty much it. So Godot is then going to automatically set this all up for us. It's going to communicate with the server. The server is then going to send a response back. And we need to make sure that this response is valid, because if it's an error, we probably want to know. So what I'm going to do, going to go to a new line here, and we are just going to go if send request doesn't equal okay. Okay, so basically if this is anything but okay, then we want to know. So we're just going to go print, and we're just going to go there was an error. Okay, so if this is not working, we're going to be sending an error. Now, what we can do is we can go down to our onRequestCompleted function. So if this request that we are sending here is successful and we receive information back, then that means this function is going to be called. And inside of this function, we can actually then see what the AI has responded. So in here, what we're going to do is we're going to delete the pass, and what we're going to do is we're going to create a variable called JSON. This is going to be equal to json.new, so we're creating a new object there. We're then going to pass the information that we got from the server, okay? And remember, this comes as a JSON format. So we need to convert that from JSON into something that we can easily access and work with in Godot. So we're going to then go json.pass, and what we want to pass is going to be our body, so that's one of the parameters, dot get underscore string underscore from underscore UTF-8. Okay, so basically what we're doing here is we are just getting the string, the string which is basically the compressed, compacted JSON format. We are then going to convert that into something that we can access. So then what we want to do, create a variable here called response equals JSON dot get underscore data. Then what we can do finally is get the message that we got as a response. So variable message equals is going to be our response. Now this response is an array with objects in it. So the first one we want to do is response. We then want to get our choices. Out of all the different choices, we want to get the first one. So the first element in our choices array is going to be 0. Then we want to get the message. And then in that message, we want to get the content, okay? And that is going to get the message that the AI has sent to us. And then what we can do is we can just print it out. So print message like so. Okay, so we have this all set up. Now, how do we actually go about testing it out? Well, pretty much we just need to call the dialog request function. So inside of the ready function, what I'm going to do is after we've set up our HTTP request node, I'm just going to call the dialog request, and let's just ask it something, okay? So then we can just talk to it as if we are talking to an AI. So I'm just going to go here, explain the Godot engine in 20 words. Save that. And if we press play, we should see after a couple seconds over here in the output, something get printed. So I'm going to press play. And if we look down here inside of the output, you'll see it says Godot is a free and open source game development engine. And yep, it basically explains that because it is responding to our request. So you can see that it does indeed work. We can change this around. We can say, for example, how do I get a node in GD script? Save that, press play. You know, just as if you're talking to ChatGPT, it's basically the exact same thing as instead though, we are talking to it inside of our Godot game, okay, which is really cool. So, as you can see down here in the output, it of course sends that information back. And there we go. Okay, hey everyone. In this lesson, we are going to begin setting up our Godot project. So here I am inside of the project manager. And the first thing we're going to do is click on the new project button, and we're going to create ourselves a new project. So for the project name, we can call this pretty much whatever we want. I'm just going to call this our AI cards game, AI card game. We can then go find a project path and create a new folder. Then click on create new folder to actually create a new folder in that directory, and click create and edit. Okay, so inside of the editor here, what we're going to do is we're going to start off by creating our base scene, which is going to be of 2D. So we'll click on 2D scene right here for the root node. Let's rename it to main, as that's what I generally like to do with my main scenes. We can then save this to our file system as main.tscn, just like so, and there we go. Now for this course, we are also going to have some assets that we need to import, and these can be found in the course files tab. There should be a downloadable assets zip file. I recommend you open that up, extract the contents, and inside you should then find a sprites folder, which contains a number of different sprites here with all these weird names, and these all correlate to a card. For example, DK stands for Diamond King, D2, Diamond 2, C3, Clubs 3. So if we open up one of these images, you can see that it is basically just an image of a card, and that is what we're going to be using. So what we're going to do is we're just going to click and drag this sprites folder into our file system here. That's going to import it. And if we open it up, you'll see that we have all of these images to use. So we can just drag and drop them in to our scene here, and there they are. But one thing you may notice is that if we zoom in, it's rather blurry, and these images by themselves are meant to be pixel art, so we do not want these blurry pixels. Now, how do we fix that? Well, what we can do is go up to Project Settings, then go down on the left-hand side to where we have our textures, and then you should see where it says Default Texture Filter. We're going to change that from Linear to Nearest. And what that's going to do is if we exit out, as you can see, all our pixels are going to be nice and crisp, and they're not going to be blurring together like before. So we can delete that card for now, since we don't need it there exactly at this moment. Something we're going to do is add in a camera, because right now, I deleted the card, but we actually need to bring it back for a second. If we bring back a card and add a couple more in here, what you'll notice is that if we press play and we click select current, as you can see, these cards are very small, and we can't really, it might be a bit hard to find the details in them. So what we're going to do is we're going to create a camera that we can then zoom in a little bit. So to do this, we're going to go ahead and create a brand new camera 2D node right here. Okay. Let's actually then move these cards over into the center. All right, so our camera 2D, if we press play again, you'll notice that the cards are still the same distance away. So what we're going to do is we're going to go down to where we have the zoom, and we're going to set the zoom to be about, let's just say 1.5, okay? So we're going to be about 50% zoomed in now. If we press play, the cards are a bit bigger, okay? So you can see now they're a bit more clear, and of course with this camera then you can add all sorts of things, camera shake, movement, but you know, we're going to probably keep a static camera for now. Something else is that the background is, well, grey. And generally, if you're playing cards, if you're playing poker, you probably want it to be on a nice green felt backdrop. So let's do that as well. Now to do that, I feel like the easiest way, if you are just having this game as your project, is to go up to Project, Project Settings, and then we can go down to where we have our textures, and underneath that you see Renderer. Not Renderer, we're going to click on Environment actually, and you see the default clear color. This is basically what color is going to be rendered if there is nothing to render on the screen pretty much. So we're going to click on this, and we are then going to move this over to a bit of a green. Okay, so let's just try and find the correct green color. I'd say something like this perhaps. There we go. We can then close out of that, press play again, and there we go. We have our nice green backdrop there. And it contrasts pretty nicely with the cards as well, I think. Okay, so we have our camera, we've got our cards, we've got our backdrop. Now, what else do we need? Well, there's a lot of things we need. So we're going to set up pretty much the basics of what a player is going to have. Now, there are going to be two players in this game. There's going to be the player, us, who we are going to refer to as me, because having two players and one of them being the player, us, is going to be a bit confusing. So from here on out, when I say me, that is going to refer to the player that we are going to control. And the player that is going to be controlled by the AI is going to be called AI. So we have me and we have AI. Now, both me and AI are going to have a number of different elements and nodes. First of all, each are going to have their 5 cards in front of them. So we are going to be at the bottom, the AI is going to be at the top, and on the left-hand side, we're going to have some text displaying our current bet and our number of chips. And for us, we are also going to have some extra buttons that are going to allow us to modify our bet and also commit to it as well as fold. Okay, so let's do that now. I'm going to delete these nodes right here since we don't need them at the moment. And I am going to go ahead and create ourselves a brand new node 2D. Now for this, I'm going to call this one me. Okay, it's in the center here. And now we need 5 cards basically just listed out. So I'm just going to go and drag in a card like this. I'm going to click on it, make it a child of me. Okay, so if we move around the me thing then, that card follows. Now with this card, we want it in the center, so let's go transform position, set that to 0, 0, 0. Now with this, we want to sort of align them horizontally here, and it's going to be pretty hard, you know, we might have to do maths with the position, but an easier way is to go up here and click on the grid snap, and that's going to enable grid snapping, which is going to allow us to do this. So with this card, we're going to have it here. We're then going to copy and paste it, or duplicate it with Control D. We're going to move it over a bit here. And then we're going to do that again over here, again on this side, and again on that side. So there we have our 5 cards. I'm going to rename them, and actually let's order them as well, just so it's a bit easier to understand. So we'll put D5 at the top here, this one here, this one there, this one there, and this one there. So we're going to rename them to card 1, card 2, card 3, card 4, and card 5. Okay, so we have our 5 different cards here, and these are going to be changed, of course, during gameplay. We're going to change their values. For the AI, we're going to have them actually have a back-facing card, so we can't actually see what they have. Now, as well as this, we also need some text on the left-hand side here explaining what our current bet is and how many chips we have. So right-click on me, add child node. We're going to create a label. Okay, press Q to go to the move tool or the select mode. And we're going to drag it over to the left-hand side here, make it a bit bigger. And then for the text, we're going to say bet, colon, and then we'll say something like 1. And then on a new line, we'll go chips, and then that'll be like 8 or something like that. Now, if you want to change the font size and change the other settings, we can go over to where we have label settings and create a brand new one of those. Open that up. We can change the line spacing. Let's just say 0, so it's a bit down, and if you want to change font, you can also change the font size here, but we're going to leave that at its default 16 for now. Let's rename this node to be our stats text, and if we press play, we can see what it looks like, and there we go. Okay, so that is pretty much the basics of what these are going to include. So we're going to have one for ourselves at the bottom and one for the enemy, or one for the AI at the top. And we're going to later on then add in more buttons for us. So for me, let's move this down here to the bottom of the screen. We are then going to duplicate it and move it up to the top. And instead of calling it me, we're going to call it AI. Okay, so we have our cards at the bottom and the AI's cards at the top. So let's save that, let's press play and see what it looks like. And there we go. Okay, so this is basically what our game is going to look like. And then when it's our turn, we're going to have some buttons on the left-hand side to allow us to basically increase, decrease our bet, fold, or commit our bet. Okay, and then the enemy, of course, the AI, will automatically do their moves. So in the next lesson, we're going to start looking at our deck, which is basically going to be a script that is going to manage all of the cards in the game. It's going to manage dealing them out. It's going to manage, shuffling them, getting a random one. And then after that, we're also going to be looking at setting up each of our individual players and having them get cards dealt to them, as well as, doing stuff when it is their turn. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be setting up our deck. So to do this, what we're going to do is we are going to go ahead and create a brand new node. Now, this isn't going to be a node 2D, but rather it is just going to be a blank node, okay? The most basic node you can create in this game. It's not going to have a position, rotation, or scale. It's just going to be an entity that exists. Now, the reason why is because this isn't going to hold any more nodes or anything visual, but rather it is just going to be holding a script, and that script is going to be in charge of our deck. So let's rename this node to be deck. Let's move it up to the top, and we're going to add also a script called deck.gd. Now, what is this script going to involve? Well, pretty much this script is going to contain an array of all of the cards in the game, as well as basically having the ability to then deal out cards and get random cards as well. So what we're going to do is we're going to remove the ready and process functions, since we are not going to be needing those, and instead we're going to create some variables. So first of all, we're going to have a variable called full deck, and this is going to be equal to a new array. Now, the elements of this array we're going to actually enter in here, and pretty much what this is going to be is it's going to be a pretty big array with a lot of stuff, but so this is what it's going to look like. And it may take you some time to go ahead and actually copy and enter all these in, but pretty much we are entering all 52 cards in our deck. So we have C2 for clubs 2, clubs 3, clubs 4, so on and so forth, all the way up to ace, jack, king, and queen. We then have the same for diamonds, for hearts, and for spades. Okay, so we have all the cards in our deck listed out right here. As an array. Now, it is important that each card name has to correlate with its corresponding sprite. Okay, so you see here, C4, we have C4 down here for 4 of clubs. And yeah, basically that's what we're going to do. So go ahead, set this up right now. You might need to pause the video as you go ahead and enter in all of these numbers right here. I'm just going to pan over so you can have a look at what they all look like. And yeah, so once you have that done, we can move on. And the next variable we need is going to be our current deck. So current deck is going to be equal to an empty array. Now, the reason why we have 2 decks here is because the full deck is going to basically be the reference, whereas the current deck is what we're actually going to be removing cards from, drawing them, and so forth. So next up, we need our me and AI. So I'm just going to create an onReady variable for me, and this is going to be equal to the me node right here. And to easily get that, we can simply just click and drag it in, like so, and it's then going to get a reference to that me node. Same thing for the AI. We can get and drag in the AI like so, and there we go. Now, we're going to have 2 functions in this script. We're going to, first of all, have a function called deal cards. Okay. And we are then going to have a function called new card. Now, the new card function is just going to basically return a random card from the current deck and then remove it as well. So to do this, we're going to create a variable called card, and this is going to be equal to our current deck, and we want to get an element from 0 to 50, 51, okay? So how do we get that? Well, to do this, we can call the roundI function. This is going to get us a random integer number from, I think, 0 to whatever the integer max limit is, so in the billions. okay? But we want to get that not in the billions, but we want to get that between our range. So to do this, we can then use the modular symbol, which is a percent, and then go current deck dot size. Okay, so pretty much what the modular operator does is it basically gets the remainder from a division. Okay, so it's basically going to divide this by this and then get the remainder. And since we are dividing a random number by 52, the remainder is going to basically be anywhere from 0 to the length of our deck. Okay, so this is basically how we can get then a random element from our array. Then what we want to do is we want to remove this card from our current deck so we don't accidentally draw it twice. So current deck dot erase card, and then we want to return the card. Now up here in the deal cards function, this is where we are going to basically deal cards to the player, to us and the enemy AI. So first of all, we need to create our current deck. So we can go current deck equals full deck dot duplicate. Okay, so this is basically going to create a copy of the array elements and set them inside of this one. Then what we can do is we can create a variable called meCards equals, we're going to create an array and we're just then going to go new card. Okay, this is basically just the brute force way. We could use a loop, but honestly, I think this is easier because we're always going to have 5 cards at the start. So we just want to paste this then, 5 times, so 3, 4, 5. We then want to do the same for the AI cards. So AI cards equals new card, new card, new card, new card, new card. And there we go. So both us and the AI are going to get 5 new random cards when the deal cards function is called. And then down here is where we are going to actually assign them to both the us and the AI. So here we'll go assign cards to me and AI. But we don't have that functionality in just yet. Instead, we're going to be working on that in the next lesson. So in the next lesson, we are going to make a start on the player script, which is what both me and the AI are going to have attached to it, which is going to manage our card sprites. It's going to manage our current cards. It's going to manage our bet. It's going to manage our chips. And yeah, that's basically going to be the controller for each of the players. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to begin looking at implementing our interaction system, okay? And this is going to basically allow us to look at an object, have a prompt appear on screen, and then basically interact with it to do whatever we want, okay? So how do we do this? Well, pretty much what we're going to do is we're going to start by creating our nodes for our player. And this is basically going to be possible by using a array cast. So I'm going to go to my player controller here. I'm going to right click on the camera 3D and add a new child node called a raycast 3D. Now a raycast 3D, the best way of thinking about this is it is basically like a laser, okay? We can point this laser in a direction and fire it off, but we can also choose how far we want to fire it, and it can then return to us information about whatever it is hitting. So by default, this raycast is pointing down, as you can see. So in the inspector, we're going to set the target position to be 0 on the X, 0 on the Y, and -2 on the Z. So now you can see that this blue line is pointing forwards here. And I'm actually going to go ahead and rename this raycast to be our interaction controller, like so. And then what we can also do is add in our text, okay? So the text is going to appear on screen when we are hovering over an interactable object, and it's going to give us a prompt so we can actually see what that interaction is going to do. And then of course we can interact. So I'm going to right click on our interaction controller, add child node, and I'm going to create a label. So this label here, as you can see, it switches us over into 2D mode because we are now working with UI. I'm just going to increase this box here. And then at the top of our viewport here, I'm going to click on this little circle green button. And this is where we can choose our anchor presets. Now, since this is going to be something in the middle of our screen, I'm going to click on the center preset right here, which is going to move the anchor points down to the center. So no matter how large or small we resize our screen, this text box is always going to maintain its central position. Then what we can do is just give it some example text. So we might have a square bracket, our key to interact, which is going to be E, and then we might have something such as a pickup item. Okay, so that's what the text would look like, for example. Let's go ahead and rename this one to be our interaction prompt. And let's also fix it up because our text looks a bit weird at the moment. It's sort of at the top left corner. So I'm going to set the horizontal alignment to be center, vertical to be center, and we can also go to label settings and create a new label settings. Open that up, go down to font, and we can increase the font size. Let's say we want to maybe make that about 24. We can then press play, see what it looks like, and there we go. So when we are hovering over an item, you could imagine that prompt appearing. Okay, so we have our text here. By default, we are going to set the text to be nothing because we don't want that appearing on screen when we're not interacting with something. And we are then going to go ahead and create two scripts. The first script down here in our file system, we can create a new script here. And this one is going to be called interactable object. So I'm going to call this one interactable object, create that. Our next script is then going to be interact controller. So I'm actually going to select our interaction controller node right here because when we create a script, that is going to automatically inherit from Raycast 3D, which is what we want. Call it interaction controller and create that as well. So now we have two scripts. We have interaction controller, which is attached to our Raycast node, and we have interactable controller, which at the moment is just existing in our file system. So let's start with the interactable object script, because this is basically what we are going to attach to everything we want to interact with. And it's going to be a pretty small script. So let's remove everything right here. We're going to give it a class name of interactable object. And we are also going to extend from node 3D, okay? Now, we are giving it the name of interactable object because basically in our other script, we want to access this node of a specific type. And giving it a class name is just going to make it easy in script to access and modify the variables and functions we have here. Now, in terms of variables, we're going to have two. We're going to export this, and this variable is going to be called interact prompt. And it's going to be of type string. And this is pretty much going to be what we want to appear or what we want to show to the player when they hover over this object. So for example, pick up item, open door, that sort of thing. We then want another export variable called can interact. And this is going to be of type boolean, and we'll make it true by default. Now, the reason why we have can interact is because we might have an interactable object that we don't want the player to interact with at a certain time. So for example, if we have a door, we might want to make it so that the player can only interact with the door when it is open or closed, not when it is maybe halfway through an animation. Okay, so at times you may want to make it so the player cannot interact with an object. And finally, we're going to have one function, and this is going to be called underscore interact. Okay, and here we are just going to print override this function. Now, what do I mean by override this function? Well, pretty much this script right here, this class, this interactable object, this is not what we are going to be attaching to our objects we want to interact with. Rather, this is going to be a script we are going to be inheriting from. Now, inheriting basically means that we are going to create a new script which is going to basically have these variables and this function, but that is going to basically already be built in. It's sort of similar to how we are extending from Node 3D here. In our player controller, we're extending from character body 3D, okay? In our player controller script, we have access to variables such as velocity and functions such as is on floor. Yet those are not variables and functions we have created in our script. Those are variables and functions that exist in our character body 3D script, which we are extending from, okay? So we are basically getting all of their functions, all of their variables, and then adding on our extra code right here. That's what we're going to be doing with our interactable object, okay? This is going to act as the parent class, and whatever children class, doors, objects, lights that we might want to turn on and off, they are all going to be inheriting this script and having access to its variables and functions. And what that also means is we can override functions. Basically, we can create an identical function in a child or inside of an inherited class, and that function is basically going to override this one right here. Now, maybe a bit confusing. We'll get to that in just a second, but let's go over to our interaction controller and begin working on this. So inside of here, we can delete the ready function since we will not be needing that, but we are going to keep the process because we will be using process. Now let's create our variables. We're going to create an onReady variable called interact prompt label. It's going to be of type label, and it's going to be equal to get node and the interact prompt right there. Okay. So now that we have our interact prompt label, we can then of course assign it inside the script here. But let's fill out the process function. So pretty much what we want to do is every single frame, we want to get whatever object we are looking at. Okay, so I'm going to create a variable called object, and this is going to be equal to get underscore collider. Now this get collider function, this is built into our raycast 3D node, which we are extending from, okay? And the raycast has a get collider function, which basically just gets the collider of whatever object it is currently hitting. Now, again, this could also be null, so we need to make sure of that. And let's also then go ahead and set our interact prompt label to be equal to an empty string here. And then down here, we are going to check to see, okay, do we have an object, and is this object of type interactable object? Because we don't want to be able to interact with a static mesh or some other sort of object that doesn't have the interaction capabilities. So here we are going to go if object, so basically if this object exists, and if object is interactable object. Okay, so if the object we are basically interacting with, if it exists, and if it is of type interactable object, then we can continue on with the if statement here. And we're just going to add in a pass for now because we're going to be working on that in the next lesson. And one more thing before we go, we need to go up here and actually fix this line of code. So this needs to be interact prompt label dot text. Okay, we are setting the text property, not the actual label itself. So in the next lesson, we are going to continue on with this function and actually create ourselves an interactable object to see it in action. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. Let's continue on with our script. So what we need to do now is first of all, we have already in the process function gotten access to whatever collider we are currently looking at. We are setting our prompt label to be empty, and then down here we are checking to see if the object we are hitting exists, and if that object is of type interactable object, then we are going to run the code down here. Now, if the object that we are looking at is it cannot be interacted, okay? In our interact object, we have that can interact boolean. If that is false, then we want to return. So if object dot can interact equals false, then return, because we don't want to do anything if we are unable to interact with it. Now, otherwise, if we can interact with it, we are going to set our prompt label. So interact prompt label dot text equals, and we're going to have the little E here so that we know what button to press, and then go plus object dot, and then we can access the interact prompt variable here. So dot interact prompt. There we go. And then finally, we need a way of actually detecting when we have pressed the interact key to then call the interact function. So here we're going to go if input dot is action just pressed interact, then we are going to go object dot interact, okay, and we are calling that interact function right here. So there we go. That is pretty much it for our interaction controller. Now let's look at actually setting up an interaction inside of our project, okay? I've got a little scene here set up with some trees and some rocks, and what I'm going to do is I am going to make it so that we are going to have these little pedestals placed around, and whenever we walk up to one of these pedestals and interact with it, it is going to turn on a light. So if we go to the models folder, this is all included in the course files tab. You should see there is a pedestal.tscn. I'm just going to drag that in here, and it is going to create us this object right here, okay? And on this object, we are going to create a new script. So we can just go ahead and, we can just create a new script on it right here. And I'm just going to call this one pedestal interaction. Okay. Now we can delete all of the code we have here, and we want to extend it from interactable object. Okay. Extending it from interactable object means that we have access to the interact function as well as these two variables here. Okay. So if we save this and we select the pedestal here in our scene view, you'll see in the inspector we have the interact prompt that we can assign. So maybe we can say turn on, and we can also enable if we can or cannot interact with it. So what we now need to do is we need to first of all set up a function that is going to override the interact function on interactable object, because remember, whenever we interact with this, it is calling this function here, and we have this print line of code. But what if we want to add our own logic? Well, to do that, we can override the function, and this is done by just creating the exact same function name. So we'll go func interact, and in here we will just print out turn on light for now, okay, just to see if it works. So what we're doing here is, since we are extending from the interactable object script, whenever we create a function with the exact same name as exists in this script, we are overriding it, meaning that when the interact function is called, it is called here instead of in the base interactable object script. So let's save this, let's press play and see if it works. So we can walk up to the pedestal here, and if I look over it, it says turn on. If I press E, you can see down in the output, it is printing out that message, which is great. Now let's make it so this light here is first of all going to start off in the off state, So let's open up that pedestal scene by just clicking on the open in editor button here. We will select the light bulb object, and this light bulb object, we want to go to visibility and disable that. Okay. So inside of our script, what we then want to do is create a variable for the light bulb. So on ready var light bulb, and this is going to equal get node, and this node here is going to just be light bulb. And then down here, when we interact with it, we are going to go light bulb dot visible equals true, and we then also want to set can interact to be false, because we only want to interact with this object once. So back in our scene here, back in our main scene, we can press play, and if we walk over to the pedestal here, turn it on, there we go. So now what we can do is we can make a little game out of this. We can actually move these around here. We can maybe make a couple duplicates and place them around the level. And now you have a little game where you have a walking simulator. You can walk up to these different pedestals, turn them on, like so. Now, of course, you can see how you can expand this into really whatever sort of game you wish. You can have a game where you might need to collect a number of things. You can have a game where you might need to complete a puzzle, and maybe when you interact with something, it moves one of the puzzle pieces. It might open you up a secret door that you can enter in. There are a lot of different things you can do with this interaction system in combination with the player controller. So yeah, thank you for watching.